Have you ever sat in a quiet room, perhaps late at night, when the world outside has finally slowed down, and simply looked at your own reflection in a mirror? It is a strange experience if you really let yourself sink into it. You see the familiar features, the eyes you have known all your life, the curve of the jaw, the texture of the skin. But if you hold that gaze for long enough, a profound and slightly unsettling question begins to rise from the silence. You start to wonder who exactly is looking at whom. You know that light is bouncing off the glass and hitting your retinas, and you know that electrical signals are racing down your optic nerves to the visual cortex at the back of your brain. But that is just mechanics. That is just machinery. The real mystery, the one that has kept philosophers and scientists awake for thousands of years, is the question of who is experiencing that image. Who is the silent observer sitting behind your eyes, feeling the sense of recognition, feeling the quiet of the room, feeling the weight of the question itself? This is the ghost in the machine. This is the sensation of being you. And despite everything we know about the universe, despite our maps of the stars and our catalogs of the periodic table, science has no explanation for why this feeling exists at all. Welcome to a journey into the deepest mystery of our existence. Tonight, we are not just going to look at the stars. We are going to look at the thing that allows us to see the stars in the first place. We are going to explore the fabric of consciousness itself, and we're going to ask if the strange, shimmering laws of quantum physics might hold the key to understanding who we really are. But before we can understand the solution, we must truly understand the problem. We must understand why your existence, the simple fact that you are aware right now, is the most impossible thing in the universe. Let us begin with what we think we know. If you were to ask a traditional neuroscientist what you are, they would point to the 3 pounds of wet, fragile tissue sitting inside your skull. They would tell you that you are a biological machine, a computer made of meat. And, to be fair, it is a magnificent machine. The human brain is the most complex structure we have ever discovered in the cosmos. It contains roughly 86 billion neurons, a number so large that if you were to count them one by one per second without sleeping or eating, it would take you over 2,700 years just to finish counting. Each of those 86 billion neurons is connected to thousands of others, creating a dense electric forest of over 100 trillion synaptic connections. It is a network vastly more complex than the entire internet, humming with electrical storms and chemical tides that never stop, not even when you sleep. In this view of the world, which scientists call materialism, everything you are is just the result of these atoms bumping into each other. Your memory of your first kiss is just a specific pattern of neurons firing in your hippocampus. The sadness you feel when you hear a minor chord is just a release of neurotransmitters in your amygdala. The color red is not a real thing existing in the world. It is just a specific frequency of light, triggering a specific electrochemical response in your visual cortex. According to this view, if we could build a computer big enough and complex enough, it would eventually wake up and feel exactly what you are feeling right now. But there is a problem with this story. It is a problem so stubborn and so difficult that the philosopher David Chalmers gave it a name that has stuck: the hard problem of consciousness. The easy problems, and mind you, they are only easy in comparison, are things like figuring out how the brain processes vision, or how it controls your heartbeat, or how it stores a phone number. Those are engineering problems. We can map the circuits, We can see the electricity flowing, but the hard problem is different. The hard problem asks, why does all that processing feel like something? Why is there an inner movie playing in your head? Think about it this way. We can build a thermostat that detects temperature. It has a sensor. When it gets too hot, a metal strip expands, completes a circuit, and turns on the air conditioning. The thermostat knows the temperature in a mechanical sense. It processes data. It reacts. But no one believes that the thermostat feels hot. No one believes that the thermostat is suffering from the heat or feeling relieved when the cool air turns on. It is just atoms moving. It is dark inside. Now, look at yourself. You are made of the exact same stuff as the thermostat. You're made of carbon, hydrogen, oxygen, nitrogen. You are a collection of atoms obeying the same laws of physics. Your neurons are just biological switches turning on and off like the switches in a computer. And yet, unlike the thermostat, it is not dark inside you. There is a light on. You don't just register the heat. You feel the sweltering discomfort of a summer day. You don't just register the wavelength of 700 nanometers. You see the vibrant, passionate redness of a rose. You don't just process sound waves. You are moved to tears by a piece of music. Why? Why doesn't all that processing just happen in the dark without any awareness like it does in a computer? Why are you a conscious being rather than a biological robot? A zombie that acts like a human but feels nothing inside. This is the paradox that keeps the materialist worldview from being complete. And it gets even deeper when we look at what you are actually made of. If we zoom in on your body, past the skin, past the cells, past the DNA helixes twisting in the dark, we eventually arrive at the atoms. And here, our intuition about reality begins to crumble. We tend to think of atoms as solid little building blocks, like microscopic billiard balls that stack together to make a person. But this is not true. This is an illusion. Let us try a thought experiment to visualize the true emptiness of your own body. Imagine we could take a single hydrogen atom from the tip of your finger and expand it until the nucleus, the proton at the center, was the size of a marble. Now let us place that marble on the center line of a massive football stadium. Where is the electron? Is it in the front row? Is it in the parking lot? In our expanded atom, with a marble-sized nucleus in the center of the field, the electron would be a tiny speck of dust whizzing around in the very highest seats of the stadium, or perhaps even drifting outside the stadium walls. And everything between the marble and the dust speck, it is empty space, vast, silent, empty void. An atom is 99.9999999% empty space. That means you are mostly empty space. The chair you are sitting on is mostly empty space. The floor beneath your feet is mostly empty space. The only reason you don't fall through the floor, and the only reason your hand doesn't pass through the table, is not because the atoms are solid, but because the electromagnetic fields of the electrons repel each other. It is force fields pushing against force fields in the void. So here is the impossible question, the one that brings us to the edge of madness if we think about it too hard. How can a collection of empty, mindless voids produce the sensation of love? How can empty space feel pain? How can a universe that is, at its fundamental level, just distinct packets of energy and fields vibrating in the silence, give rise to the rich, colorful, emotional experience of being you? If we accept the standard view of classical physics, the view that the universe is just a giant clockwork mechanism of dead matter interacting with other dead matter, then consciousness should not exist. It is a miracle that doesn't fit the equation. It is a ghost in a machine that shouldn't have ghosts. For centuries, science tried to ignore this problem. It was too hard. It was too philosophical. It was not real science. But in the early 20th century, something happened that shook the foundations of this clockwork universe. Physicists began to peer into the heart of the atom, and what they found there didn't follow the rules. They found that matter wasn't behaving like hard little balls. It was behaving like waves. It was behaving like smoke. It was behaving in ways that seemed to depend on whether or not someone was watching. The pioneers of this new physics, men like Max Planck, Erwin Schrödinger, and Niels Bohr, were not just technicians. They were deep thinkers who realized they had stumbled onto something that shattered the separation between the observer and the observed. Max Planck, the father of quantum theory and a man of rigorous scientific discipline, looked at the data, looked at the mystery of the atom, and came to a startling conclusion. He said, "I regard consciousness as fundamental. I regard matter as derivative from consciousness. We cannot get behind consciousness." Think about the weight of that statement. The man who discovered the energy quanta, the building blocks of the physical world, is telling us that the physical world might not be the foundation of reality. He is suggesting that consciousness, that invisible, unmeasurable ghost behind your eyes, might be the one thing that is truly real, and matter itself is just a shadow cast by the mind. Could he be right? Could it be that for 300 years we have been looking at the universe upside down? We have been trying to explain how matter creates mind, but perhaps we should have been asking how mind creates matter. This is the journey we are about to undertake. Over the next chapters, we are going to explore the strange landscape of quantum mechanics, not as a dry academic subject, but as a map to your own soul. We are going to look at experiments that show how a particle can be in two places at once, until you look at it. We're going to look at connections that defy space and time, linking hearts and minds across the cosmos. We are going to explore the possibility that your brain is not a computer, but a quantum antenna, tuned to a frequency that existed before the stars were born. We will walk this path gently. We will take our time, because these ideas are big and they require a quiet mind to truly absorb. We are going to drift through the double-slit experiment, float through the quantum vacuum, and dive into the microtubules inside your neurons. We are going to ask what happens when we die, and we are going to ask what it means to be alive. So, take a deep breath. Let the tension of the day fade away. Let the certainty of the solid world soften a little edges. You are not just a machine made of meat. You are a mystery wrapped in a paradox, floating in a universe that is far stranger and far more beautiful than we ever dared to imagine. The clockwork universe is dead. The quantum universe is alive. And you are at the very center of it. As we prepare to step through the looking glass, remember the question we started with, the face in the mirror, the silence in the room, the feeling of being. If matter is mostly empty space, and if the laws of physics are just the rules of the game, then who is the player? Who is the watcher? The answer might be waiting for us in the space between the atoms. It might be waiting in the quantum silence. Let us drift deeper into the mystery. In the previous chapter, we stood before the mirror and asked who was looking back. We dismantled the solid world and found that the chair, the floor, and your own hand are made almost entirely of empty space, held together by invisible fields of force. We realized that The standard story that you're just a machine made of meat leaves us in the dark, unable to explain the brilliant inner light of your own awareness. Now we must take the next step. We must leave the macroscopic world of chairs and tables behind and descend into the subatomic basement of the universe. We are going to visit a quiet, dark laboratory in our minds, where a simple experiment shattered our understanding of reality and hinted that consciousness might be far more powerful than we ever dared to dream. Imagine a room of absolute darkness. It is perfectly silent, perfectly still. In the center of this room, there is a device, a simple gun, that fires tiny particles of matter one by one. Let us say they are electrons, those tiny, frenetic ghosts we imagined whizzing around the marble in the football stadium. In front of this gun, there is a barrier, a solid wall with two narrow vertical slits cut into it. And behind that barrier, there is a back wall, a screen that glows with a tiny spark of light whenever an electron hits it. This is the setup for the famous double-slit experiment. It sounds simple, almost like a high school science project. But what happens in this dark room is the closest thing to magic that science has ever discovered. It is the experiment that the great physicist Richard Feynman said contained the only mystery of quantum mechanics. First, let us think about what should happen in a sensible, clockwork universe. If you were standing there throwing tennis balls at a wall with two holes, some of the balls would bounce off the wall and some would go through the holes. If you threw enough of them, you would expect to see two piles of tennis balls on the other side, one pile behind the left hole and one pile behind the right hole. This is how matter behaves. It is solid. It has a trajectory. It is here, or it is there. It follows a straight line until it hits something. This is the logic of the world we live in, the logic of cause and effect, the logic of separate things. So the physicists turned on the electron gun. They fired the electrons one at a time. Click, click, click. They watched the sparks appear on the back screen. At first, everything seemed normal, but as they let the experiment run, as thousands of tiny sparks accumulated on the back screen, a pattern began to emerge that made no sense. Instead of two bands of electrons directly behind the two slits, they saw many bands. They saw a central band of high intensity, then dark gaps, then more bands, fading out to the edges. It looked like the ripples on a pond when you throw two stones in at once. The ripples overlap. Where two crests meet, the water goes higher, and where a crest meets a trough, the water goes flat. This pattern, this interference pattern, meant only one thing. The electrons were not behaving like little tennis balls. They were behaving like waves. They were behaving like water. But how can a single electron be a wave? Does it split in half? Does it dissolve? The math suggested something even stranger. It suggested that as the electron traveled from the gun to the screen, it did not take a single path. It went through the left slit. It went through the right slit. It went through both slits. It went through neither slit. It took every possible path simultaneously. The electron was not a solid thing located in one place. It was a ghost of pure possibility, a wave of probability spreading out through the darkness, flowing through both doors at once and interfering with itself on the other side. This is the first shock of the quantum world. Matter, the stuff you are made of, is not solid when no one is looking. It is a smear of potential. It is a cloud of maybe. Before it hits the screen, the electron does not exist in a specific location. It exists in a superposition, a state of being everywhere and nowhere at the same time. But the physicists were stubborn. They couldn't believe that matter was this ghostly. They thought, We just need to see which hole it actually goes through. So, they modified the experiment. They placed a tiny detector, a microscopic measuring device, right next to the slits. This detector would not stop the electron. It would just watch it. It would beep, metaphorically speaking, if the electron went through the left slit or the right slit. They wanted to catch the ghost in the act. They wanted to force the universe to make sense. So, they ran the experiment again. The room was dark. The gun fired. Click, click, click. The detector did its job. It saw the electron go through the left slit, or it saw it go through the right slit. The mystery of the wave seemed to be solved. They knew where the particle was. But then, they looked at the back screen, and this is the moment where the universe grabbed them by the shoulders and shook them awake. The interference pattern was gone. The beautiful ripples of probability had vanished. Instead, there were just two boring bands of electrons, exactly like the tennis balls. Do you understand what happened? The moment they looked, the behavior changed. The moment they measured the electron, it stopped acting like a wave of infinite possibility and snapped into being a solid particle of limited reality. It was as if the electron knew it was being watched. It was as if the act of observation forced the universe to decide. Okay, the electron seemed to say, you are looking at me, so I have to be somewhere. I will be here. This is called the collapse of the wave function, and it is the crack in the wall of materialism where the light of consciousness shines through. In the classical view, the observer is separate from the experiment. You are just a passive camera, recording what happens. But quantum mechanics tells us that this is a lie. The observer is not separate. The observer is a participant. The act of knowing changes the known. When you look at the world, you're not just seeing what is already there. Your gaze is helping to sculpt what is there. You are dragging reality out of the hazy realm of quantum possibility and freezing it into the solid world of experience. Think about what this implies for you, sitting there in your quiet room. If the fundamental building blocks of your body and your brain are quantum particles, and they are, then you are a walking, breathing collapse of the wave function. You are a localized storm of reality in a sea of probability. But let us go deeper. Let us ask the question that the pioneers of quantum physics were forced to ask. What counts as an observer? Is it just the metal detector? Is it the computer recording the data? Or does it require a conscious mind to truly collapse the wave function? Erwin Schrödinger, the man who gave us the famous equation for the wave function, struggled deeply with this. He created his famous thought experiment about the cat in the box, alive and dead at the same time, to show how absurd it was to apply quantum rules to everyday objects. But he also saw the profound implication. If the universe remains in a state of superposition until it is observed, then consciousness cannot just be a byproduct of the universe. It must be a fundamental ingredient. The physicist John Wheeler, one of the giants of 20th century science, took this idea to its ultimate conclusion. He proposed the participatory anthropic principle. He suggested that the universe is a self-excited circuit. He drew a diagram of a giant U-shape, representing the universe starting at the Big Bang and evolving over billions of years. At the end of the U, there is an I, a conscious observer, looking back at the beginning. Wheeler was suggesting that by looking at the universe, we are actually creating it. We are not just inhabitants of the cosmos. We are its architects. Our consciousness is the mechanism by which the universe becomes real to itself. Let that sink in for a moment. feel the weight of it. We are taught to feel small. We are taught that we are accidental specks of dust in a vast indifferent void. We are taught that if humanity disappeared tomorrow, the universe would tick on, indifferent and unchanged. But quantum mechanics whispers a different story. It whispers that without us, or without some form of consciousness to bear witness, the universe might just be a silent, ghostly ocean of overlapping waves, a song with no one to hear it, a story with no reader. Does the moon exist when you're not looking at it? Albert Einstein asked this question in frustration, trying to defend the old, solid reality. He wanted to believe that the moon is there, solid and heavy, regardless of whether a mouse or a man is looking at it. But in the quantum world, the answer is not a simple yes. The answer is, it depends on what you mean by exist. As a probability? Yes. As a solid object in a specific location? Maybe not. This brings us back to the hard problem of consciousness. Remember the question, why does it feel like something to be you? Why is there a light on inside? Perhaps the answer is that this light, this awareness, is not something the brain creates to help you find food or mates. Perhaps this awareness is the fundamental force that collapses the quantum probabilities into the reality we experience. Perhaps your brain is not a generator of consciousness, but a receiver of it. Imagine a radio. The radio plays music, Mozart, jazz, the news. If you smash the radio, the music stops. A primitive person might think that the music was being made inside the box by the little wires and tubes. They might think that by smashing the box they killed the orchestra. But we know better. We know the signal is still there, in the air, invisible and pervasive. The radio was just a tool to catch the signal and give it form. What if your brain is a quantum radio? What if the universe is humming with a field of proto-consciousness, just like it hums with electromagnetic fields and gravitational fields? And what if the complex, wet, chaotic structure of your brain has evolved not to produce this field, but to tune into it? This is a radical idea. It sounds like poetry, or perhaps mysticism. But in recent decades, serious scientists have begun to look for the antenna. They have begun to look for the structures inside the brain that could possibly interact with the delicate, ghostly world of quantum mechanics. They are looking for a bridge between the wet biology of neurons and the shimmering math of the wave function. And they may have found it. Deep inside your cells, there is a structure called the cytoskeleton. It is the scaffolding that holds your cells together. And part of this scaffolding is made of tiny microscopic tubes called microtubules. For a long time, biologists thought these were just structural supports, like the steel girders in a skyscraper. But physicist Sir Roger Penrose and anesthesiologist Stuart Hameroff have proposed a theory that these microtubules are actually quantum computers. They argue that inside these tiny tubes, isolated from the noise of the rest of the brain, quantum states can exist. They suggest that the collapse of the wave function happens here, millions of times a second, and that each collapse is a tiny spark of simple consciousness. According to this theory, known as orchestrated objective reduction, your stream of consciousness, the continuous flow of thoughts, feelings, and perceptions, is actually a rapid-fire sequence of quantum moments. You are literally rippling through the fabric of space-time, collapsing probabilities into reality with every heartbeat, with every thought, with every glance. If this is true, then you are not separate from the universe. You are an intrinsic part of its unfolding. The boundary between in here and out there begins to dissolve. When you look at a star, the photons from that star have traveled for millions of years across the empty dark. They were waves of probability spreading out across the galaxy. But the moment they hit your retina, the moment your consciousness registers star, you have completed their journey. You have collapsed their wave function. You have made them real. This is a lot to absorb. It turns our view of the world inside out. It replaces the lonely, mechanical universe with a participatory, interconnected cosmos. It suggests that your attention is a sacred power. Where you direct your focus, you are bringing a world into being. As we end this chapter, I want you to return to the silence of your room. Look around you. Look at the shadows in the corner. Look at the light falling on your hands. Try to hold the idea that what you are seeing is not a fixed, static stage set, but a fluid dance of quantum possibilities that is settling into this shape because you are here to witness it. You are the observer. You are the witness. And without you, the double-slit experiment remains a blur of ripples. With you, it becomes a world. But this raises an even bigger question. If our individual consciousness is collapsing the wave function, what connects us? Why do we all see the same moon? Why don't we live in separate, private dream worlds? Is there a deeper level of connection? Is there a field that binds all observers together? In the next chapter, we will explore the phenomenon of quantum entanglement, what Einstein called spooky action at a distance. We will see how two particles, once united, remain connected across the infinite distances of space, feeling each other's changes instantly, faster than the speed of light. And we will ask if our minds, too, are entangled in a vast, invisible web of being. Rest now in the mystery. You are the quiet center of the storm. You are the eye of the universe. In the last chapter, we stood alone in the dark, watching the electron dissolve into a ghost of possibility until our gaze forced it to become real. We explored the idea that your consciousness is the anchor that holds the physical world in place, collapsing the wave function into the chair you sit on and the air you breathe. It is a powerful thought, but it can also be a lonely one. If you are the observer creating your reality, and I am the observer creating mine, do we live in separate bubbles? Is the moon you see the same as the moon I see? Or are we just dreaming near each other, forever isolated by the walls of our own skulls? Tonight, we are going to dismantle the walls. We are going to take the most counterintuitive, the most spooky, to use Albert Einstein's own word, concept in all of physics, and we are going to see if it can weave us back together. We are going to explore quantum entanglement, and in doing so, we might just discover that the distance between you and the person you love, or between you and a star burning 1 billion light years away, is nothing but a stubborn illusion. Let us return to our imaginary laboratory. Clear the table. Turn off the electron gun. This time, we need something more delicate. We need a special crystal, the kind that can take a single photon of light, a single packet of pure energy, and split it into two. Imagine this crystal sitting in the center of the void. We fire a blue laser into it. Phew! Out come 2 red photons. But these are not just any 2 photons. They are born from the same moment, from the same energy source. They are twins. In the language of quantum mechanics, they are entangled. Now, let us play a game with the universe. Let us keep one of these photons here on Earth, perhaps in a lab in Vienna. Let us take the other photon and put it on a spaceship. Let us send that spaceship flying away at the speed of light, out past the moon, past Mars, past the icy rings of Saturn, until it reaches the Andromeda galaxy, 2.5 million light years away. So, here is this situation. You have one tiny speck of light in a box on Earth. You have its twin in a box in another galaxy. They are separated by a gulf of space so vast that the human mind cannot truly comprehend it. To a classical physicist, to Isaac Newton, or even to the young Einstein, these two particles are now completely separate objects. They have their own lives, they have their own properties. What happens to one should have absolutely no effect on the other, unless you send a message between them, which would take millions of years. But quantum mechanics laughs at distance. We open the box on Earth. We decide to measure a property of our photon. Let us say we measure its spin, which is a bit like asking if it is spinning clockwise or counterclockwise, or pointing up or down. But remember the lesson of the double slit. Before we look, the photon has no fixed spin. It is spinning both ways at once. It is in a superposition of up and down. We look, snap. The wave function collapses. The photon decides, I am spinning up. Here is the magic. At that exact same instant, not a second later, not a millisecond later, but instantaneously, the photon in the Andromeda galaxy, 2 million light years away, snaps into the opposite state. If we measured ours as up, the other one immediately becomes down. If we had measured ours as down, the other one would have become up. It doesn't matter if we decide to measure it today or tomorrow. It doesn't matter if we measure it on Earth or on Mars. The moment one partner chooses a reality, the other partner, across the infinite dark, responds. It is as if they are not two separate particles at all, but a single object stretched across the universe. It is as if space, the thing that we think separates here from there, does not exist for them. Albert Einstein hated this. He absolutely hated it. He called it spukhafte Fernwirkung, spooky action at a distance. To him, it smelled of sorcery. It violated the cosmic speed limit. Nothing can travel faster than light, he argued. If the particle on Earth communicates with the particle in Andromeda instantly, it is breaking the fundamental law of relativity. He spent the last decades of his life trying to prove that this couldn't be the whole story. He argued that there must be hidden variables, secret instructions written inside the particles from the moment of their birth, telling them what to do. He wanted the universe to be local, sensible, and safe. But he was wrong. In the 1960s, a physicist named John Bell came up with a way to test Einstein's objection. He created a mathematical theorem, Bell's theorem, that could determine if the particles were communicating instantly or just following pre-written instructions. And when the experiments were finally done in the 1980s by Alain Aspect and others, the results were unequivocal. The particles were not following hidden instructions. They were genuinely, impossibly connected. Einstein's spooky action was real. The universe is non-local. Stop for a moment and let that wash over you. Non-local. It means that location is not the ultimate truth. It means that separation is a convenient fiction we use to navigate the world, but it is not the fundamental nature of reality. Underneath the appearance of distance, underneath the miles and the light years, there is a fabric of connection that is tighter than intimacy, faster than time. Now, let us bring this back to you. Let us bring this back to consciousness. If tiny photons can be entangled, what about the atoms that make up your body? What about the neurons in your brain? Think back to the Big Bang, 13.8 billion years ago. In that first primordial moment, all the matter and energy in the universe was compressed into a single point, infinitely hot, infinitely dense. Every electron, every quark, every photon that exists today was touching every other particle. We were all smashed together in a singularity of pure oneness. Then the explosion, the expansion, The universe inflated, scattering those particles across the billions of light years of the cosmos. Some became stars, some became dust, some became the carbon in your left hand, some became the iron in the blood of a person walking down a street in Tokyo. Some became the ice on a moon of Jupiter. But if quantum entanglement holds true, then the fact that we were once touching means that, in some deep quantum sense, we are still touching. We are all still entangled parts of that original singularity. The separation between you and the star, or you and the tree, or you and your neighbor, is just a trick of the light. This offers a profound new way to look at consciousness. If our brains are quantum systems, as we discussed with the microtubules in the last chapter, and if quantum systems can be entangled, then perhaps our minds are not isolated islands. Have you ever had the feeling of knowing something was wrong with a loved one, even though they were thousands of miles away? Have you ever felt a sudden pang of anxiety, only to pick up the phone and find out your mother was sick? Science usually dismisses these stories as coincidence. Just random chance, they say. Confirmation bias. But in a non-local universe, is it really so impossible? If two photons can feel each other across a galaxy, is it so strange to imagine that two minds, which have spent years in the deep resonance of love or friendship, might remain entangled? Perhaps love is not just an emotion. Perhaps love is a biological form of quantum entanglement. Perhaps when we bond with someone, our wave functions overlap and we become a single system. The physicist David Bohm, one of the most original thinkers of the 20th century, proposed a model of the universe called the implicate order. He suggested that the world we see, the world of separate chairs, tables, and people, is the explicate order, the unfolded reality. But underneath it, there is a deeper, enfolded reality where everything is one. He used the metaphor of a hologram. If you cut a hologram in half, you don't get half the picture. You get the whole picture, just a little fuzzier. Every part of the hologram contains the information of the whole. Bohm believed that consciousness is not something that happens in the brain, but rather that the brain is a way for the implicate order to unfold into a specific experience. We are like waves on the ocean. We look separate. We rise and fall as individuals. But we are all made of the same water, and we are all moved by the same deep currents. This changes everything about how we see ourselves. If you are entangled with the universe, then you are never truly alone. The silence of the empty room is not empty. It is humming with the invisible threads of connection that bind you to the supernova, to the blade of grass, and to the person sitting in a room halfway across the world, wondering the same things you are. It suggests that empathy, the ability to feel what another is feeling, is not just a psychological trick. It is a physical reality. When you see someone suffer and you feel a tightening in your own chest, you are vibrating the web. When you see a sunset and feel a sense of awe, you're sharing that frequency with the cosmos. Maybe this is why we feel such a deep longing for connection. Maybe loneliness is just the illusion of the explicate order, trying to overshadow the truth of the implicate order. We miss the oneness because we are the oneness, momentarily pretending to be many. There is a beautiful term in quantum physics called decoherence. It describes how a quantum system loses its connection to the whole and becomes a separate, classical object. It happens when the system interacts too much with the noisy environment. The delicate threads of entanglement get tangled up and lost in the static. In a way, our busy lives are a constant state of decoherence. The noise, the stress, the constant distraction, they break our sense of connection, They make us feel solid, separate, and small. But in moments of deep silence, in meditation, in the flow state of art or sport, or in the presence of overwhelming beauty, we might be quieting the noise enough to feel the entanglement again. We might be recohering with the universe. So, as you sit there, visualizing the invisible web that connects your heartbeat to the rhythm of the spinning galaxy, ask yourself, what would it mean to live as if this were true? How would you treat the stranger on the bus if you knew that at a quantum level you are parts of the same original spark? How would you treat the earth if you felt the entanglement between your breath and the forests? The ghost in the machine is not a lonely ghost. It is a part of a vast spectral choir. But the mystery deepens even further. We have talked about connection across space. We have seen that here and there are blurry concepts. But what about now and then? What about time? If space is an illusion, could time be an illusion too? In the next chapter, we are going to look at experiments that seem to suggest that the future can affect the past. We are going to look at the quantum eraser experiment, where a choice made now seems to change what a particle did yesterday. We are going to ask if your consciousness is flowing through time in a straight line, or if you are spread out across your own history, entangled with the child you were and the elder you will become. Prepare to let go of the ticking clock. We are about to step into the timeless. In the silence of the night, when the world is asleep and the only sound is the rhythmic beating of your own heart, it is easy to feel the weight of time. We feel it as a river that flows in only one direction, carrying us relentlessly from the past through the fleeting present and into the uncertain future. We remember the past, the mistakes, the triumphs, the lost loves, the childhood summers, as if it were a landscape carved in stone, fixed and unchangeable. We look to the future as a blank canvas, a realm of possibility that has not yet been written. This is the story our intuition tells us. This is the story the clock on the wall tells us with every ticking second. Cause comes before effect. The glass falls, and then it shatters. The sun rises, and then the flowers open. It seems fundamental, undeniable, and absolute. But what if I told you that in the quantum world, the basement of reality, where the foundations of your consciousness are built, this story is a lie? What if the arrow of time is not a straight line, but a circle, or a loop, or a smear? What if the choices you make right now, in this quiet moment, are rippling backwards through the fabric of history, changing the events of yesterday? Welcome to the most mind-bending chapter of our journey. We have explored how consciousness collapses the wave function. We have explored how entanglement connects us across the vastness of space. Now, we must confront the illusion of time itself. We are going to examine an experiment so strange that it seems to violate the basic logic of the universe, suggesting that the future can reach back and rewrite the past. This is the delayed choice quantum eraser. To understand this, we must return to our laboratory of shadows and light. But this time, we are not just playing with a space, we are playing with chronology. Imagine the setup. We have our laser, our double slits, and our crystal that splits a single photon into two entangled twins. Let us call them Photon A and Photon B. They are born from the same quantum womb, inextricably linked. Whatever happens to one instantly affects the other, as we learned in the last chapter. In this experiment, we send Photon A directly to a screen to be recorded. It has a short journey. It hits the screen and makes a mark. But Photon B, the twin, is sent on a much longer, more complicated journey through a maze of mirrors, prisms, and detectors. Because its path is longer, photon B will arrive at its destination a few nanoseconds after photon A has already hit the screen. In the world of light, a nanosecond is a long time. It is a distinct after. So, the timeline is clear. Event 1 is photon A hitting the screen. Event 2 is photon B reaching its detectors. The past happens, and then the future happens. Now, here is the twist. The maze that photon B travels through is designed to ask a specific question. Which path did you take? We have detectors set up that can tell us if the photon came from the left slit or the right slit. If we know the which path information, the wave function collapses, and the photon behaves like a particle. But, and this is the crucial part, we also have a way to erase that information. We can scramble the path of photon B so that, even after it passes through the slits, we destroy the evidence of where it came from. We make it impossible to know which path it took. This is the quantum eraser. So, the experiment begins. Photon A flies off and hits the screen. Smack. It is done. Its history is recorded. It is a spot on a photographic plate. It is the past. Meanwhile, photon B is still flying through its maze. It hasn't reached the detectors yet. It hasn't decided whether to give up its path information or to have it erased. That decision to measure or to erase happens in the future relative to photon A's arrival. If common sense held true, what happens to photon B in the future should not matter to photon A in the past. Photon A has already landed. The ink is dry. But the universe does not care about our common sense. When the physicists look at the data, they find something impossible. If they choose to erase the path information of photon B, an event that happens after photon A has landed, then photon A creates an interference pattern on the screen. It behaves like a wave. It acts as if it went through both slits. However, if they choose not to erase the information for photon B, if they let the detectors record which path it took, then photon A, back in the past, creates a clump pattern. It behaves like a particle. It acts as if it went through only one slit. Read that again. Let the vertigo set in. The choice made in the future, to erase or not to erase, determined how the photon behaved in the past. It is as if photon A, sitting on the screen, waited to see what its twin would do in the future before deciding what it had done in the past. It is as if the history of photon A was not written in stone until the future had been observed. This is called retrocausality. It suggests that the timeline is not a rigid sequence of dominoes falling one by one. Instead, it is a dynamic, fluid web of relationships, where the now is in constant conversation with the then. The great physicist John Wheeler, who first conceived of the delayed choice experiment, took this idea to a cosmic scale. He imagined light from a distant quasar, billions of light years away, traveling toward Earth. On its way, the light passes a massive galaxy that acts as a gravitational lens, bending the light so it can take two paths around the galaxy to reach us. The light left the quasar billions of years ago. It passed the galaxy millions of years ago, long before the Earth was formed, long before the dinosaurs, long before you were born. But today, tonight, an astronomer points a telescope at that light. The astronomer can choose to measure which path the light took around the galaxy. Or they can choose to measure the interference pattern, treating it as a wave that took both paths. According to quantum mechanics, the astronomer's choice right now determines whether the photon took one path or two paths billions of years ago. Wheeler said, "The past has no existence except as it is recorded in the present." He meant that history is not a dusty book sitting on a shelf. History is a quantum phenomenon that is only realized when we interact with it in the now. We are not just the products of the past. In a very real, physical sense, we are the creators of it. What does this mean for the ghost in the machine? What does this mean for the consciousness that feels like it is trapped in the flow of time? It suggests that your memory is not just a passive playback of a video recording. Neuroscientists have known for a long time that memory is reconstructive. Every time you remember your first kiss or the day you learned to ride a bike, you are not pulling a file from a cabinet. You are rebuilding the neural pattern from scratch. You are modifying it. You are coloring it with your current emotions. But quantum physics adds a deeper layer to this. It suggests that the past itself, the actual physical trajectory of the atoms that made up those moments, might be in a state of superposition until you observe it in the present. It suggests that you are constantly resolving the ambiguity of your own history. Think about trauma. Think about regret. We often feel chained to the events of our past, defined by things we did or things that were done to us. We feel that the concrete has hardened and we are stuck in the shape we were cast in. But the quantum eraser whispers a message of liberation. It says that the past is softer than we think. It says that the information about what happened is still entangled with the present. Perhaps the act of forgiveness, or the act of understanding, or the act of reframing a story in therapy is a form of quantum erasure. Perhaps when we change our perspective on a past event, we are literally altering the which path information of our own timeline. We are changing the interference pattern of our lives from a chaotic scatter of pain into a coherent wave of meaning. This might sound like magic, but remember, the distinction between the hard world of physics and the soft world of experience is an illusion. Your brain is a quantum instrument. Your neurons are firing in the now, but they are entangled with the traces of the then. If the universe allows a photon to rewrite its history based on a future choice, why should the complex quantum storm of your consciousness be any different? There is a concept in philosophy called the specious present. It is the idea that the now we experience is not an infinitesimally thin razor edge between past and future. It is a duration. It has thickness. It is a saddleback of time that includes a bit of the immediate past and a bit of the immediate future. In the quantum view, this specious present might be the zone of coherence, the window of time where the wave function has not yet fully collapsed. Within this window, the order of events is not fixed. The future bleeds into the past, and the past bleeds into the future. You are living in a moment that is smeared out across time. Imagine a piece of music. When you hear a melody, you are not just hearing the single note being played at this exact millisecond. If you did, you would not hear music. You would hear a series of disconnected beeps. To hear a melody, your consciousness must hold the previous note in suspension while anticipating the next note. The now of the music contains the ghost of the past and the shadow of the future simultaneously. The melody exists only in the relationship between the notes, in the non-local connection across time. Your life is a melody. Your consciousness is the listener that strings the isolated moments into a song. And just as the end of a musical phrase can change the emotional meaning of the beginning, turning a major chord into a minor resolution, your present choices can change the emotional and perhaps even the physical resonance of your past. This brings us to a profound realization about the nature of destiny. If the future can affect the past, then we are not just pushed from behind by the engine of cause and effect. We are also pulled from ahead We are drawn toward attractors, toward future states of coherence. The universe is not a clockwork machine winding down. It is a handshake across time. The Big Bang at the beginning of time and the final state of the universe at the end of time are entangled. They are shaking hands. And you, with your beating heart and your wondering mind, are standing in the middle, holding the tension. So, tonight, as you lay in the dark, think about the things you wish you could change. Think about the what-ifs. And then, try to let go of the idea that they are set in stone. The quantum universe is a place of infinite second chances, because the first chance hasn't really finished happening yet. The wave function of your life is still spreading out. The interference pattern is still forming. You are a time traveler. You do not need a machine of brass and crystal. You do not need a wormhole. You are doing it right now. With every breath, you are collapsing the probability of the future and refining the probability of the past. You are weaving the timeline. But if time is fluid, and if choices branch out into infinite possibilities, then we must ask the next inevitable question. Where do the other choices go? When the photon chooses the left slit, what happens to the version of the photon that chose the right slit? Does it disappear? Does it die? Or does it continue on in a shadow world, in a parallel reality that is just as real as this one? In the next chapter, we are going to face the most vertiginous idea in all of physics, the many worlds interpretation. We are going to ask if there are infinite versions of you, living out every possible life, making every possible choice, in a vast, branching multiverse of consciousness. We are going to ask if you are alone in your own head, or if you are a choir of selves singing across dimensions. The silence of the room is deep. The clock on the wall ticks. But now you know. The tick is not a command. It is just a suggestion. In the deep silence of the night, when the noise of the day has finally settled and the mind is left to wander through the corridors of memory, we often find ourselves haunted by the ghosts of the unchosen. We think about the paths we did not take. We think about the person we did not marry, the city we did not move to, the words we did not say when we had the chance. We look at our lives and see a single linear story, a sequence of events that has led us to this specific room, this specific chair, this specific moment of reflection. We feel the weight of inevitability. We feel that reality is a singular hard road and that all the other possibilities, the dreams, the what-ifs, are just fantasies, smoke that vanished the moment we made a choice. We believe that for one thing to happen, everything else had to not happen. This is the tragedy of the human condition, the feeling that we are constantly pruning the tree of our lives, cutting off branches of possibility until we are left with only one withered stick of reality. But what if the physics of the universe tells a completely different story? What if the feeling of loss is the illusion and the feeling of infinite possibility is the truth? What if I told you that in the quantum world, nothing ever truly vanishes? What if every choice you have ever made and every choice the universe has ever made is still happening right now in a space that is just millimeters away from your skin, but vibrating at a frequency you can no longer hear? Welcome to the most vertiginous, the most overwhelming, and perhaps the most comforting chapter of our journey. We have stood at the double slits and watched the electron collapse. We have touched the spooky threads of entanglement. We have watched the future rewrite the past. Now we must face the many worlds interpretation. We must face the possibility that you are not a single person living a single life, but a vast, shimmering choir of selves, singing every possible song of existence simultaneously across an infinite multiverse. To understand this, we have to go back to the central mystery of quantum mechanics, the collapse of the wave function. Remember the electron. Before we measure it, it is a wave. It is in a superposition of here and there. It is a cloud of probability. But the moment we look, it snaps into a single point. For decades, physicists accepted the snap as a fundamental law of nature. They called it the Copenhagen interpretation. They said that the act of observation forces nature to choose. Nature rolls the dice, and the dice land on 3, and all the other numbers disappear. It is a view of the universe that is inherently random and inherently destructive. It says that possibility is constantly being destroyed to make way for reality. But in 1957, a brilliant young doctoral student at Princeton University named Hugh Everett III looked at the mathematics of the Schrödinger equation, the holy grail of quantum physics, and he realized something startling. The equation itself does not have a collapse in it. The math does not say that the wave function stops and a particle appears. The math says that the wave function just keeps going. It keeps evolving. It keeps rippling. Everett asked a simple, dangerous question. What if the collapse never happens? What if the electron never chooses? What if, when the electron is faced with the choice of going left or going right, it actually does both? But, you might ask, if it does both, why do I only see one? If the cat is both alive and dead, why do I only ever find a living cat or a dead cat? Everett's answer was a stroke of genius that shattered our conception of the self. He said that when you measure the electron, you don't force it to collapse. Instead, you become entangled with it. You, the observer, are a quantum system too. You are made of atoms. You obey the same laws. So when you look at the electron that is in a superposition of left and right, you enter a superposition yourself. The universe splits in one branch of reality. There is a version of you that sees the electron go left. In another branch of reality, there is a version of you that sees the electron go right. Both versions of you are equally real. Both versions feel that they are the true you. Both versions look back at history and see a single, consistent story. But they are now separated by an invisible wall of decoherence. They can no longer communicate. They can no longer see each other. They have become orthogonal, vibrating at right angles to one another in the vast high-dimensional landscape of the universe. This is the many worlds interpretation. It suggests that reality is not a single timeline, but a violently branching bush of universes growing denser and more complex with every passing nanosecond. Think about what this means for the sheer scale of existence. Every time a subatomic particle interacts with another, which happens trillions of times a second in every cubic centimeter of space, the universe branches. The universe is splitting right now as you read this sentence. It is splitting as your heart beats. It is splitting as the photons from your screen hit your retinas. Imagine a garden of forking paths, but a garden where you take every path. In one universe, you pause to drink a glass of water before reading the next paragraph. In another, you didn't. In one universe, a cosmic ray hit a DNA strand in a cell in your body and caused a mutation. In another, it missed. In one universe, the asteroid that killed the dinosaurs missed the Earth by a few thousand miles, and human beings never evolved. In another, the Earth is a barren rock. In another, you are exactly the same, but you are wearing a blue shirt instead of a red one. This sounds like science fiction. It sounds like a story we tell to make ourselves feel important. But many of the world's leading physicists, men and women who have spent their lives studying the rigorous mathematics of the cosmos, believe that this is the most logical, most parsimonious explanation for the data we have. They believe it because the math works perfectly without adding any magic collapse mechanism. The wave function simply encompasses everything. There is a universal wave function, a single majestic mathematical object that contains every possible configuration of the universe within it. So, where are these other worlds? They are not far away in the sense of distance. They are not in another galaxy. They are right here. They are superimposed on top of us. Think of a radio. The air around you is filled with hundreds of radio signals, jazz, classical, pop, news, static. They are all occupying the same space at the same time. They are all passing through your body right now. But your radio is tuned to only one frequency. It only picks up one station. To the radio, the jazz station is the only reality. The classical station is just a ghost, a potentiality that it cannot hear. In the many worlds view, your consciousness is the radio. You are tuned to a specific frequency of reality, a specific track through the multiverse. This track is defined by the consistent history of your memories, but the other frequencies are still there. The versions of you who made different choices, who lived different lives, are just as real, just as conscious, just as here as you are. They are just phase shifted. They are playing a different song in the same room. Now, bring this back to the silence of your reflection. Bring this back to the feeling of the ghost in the machine. If there are infinite versions of you, what does that mean for your soul? Does it dilute the meaning of your life? Or does it expand it to an infinite magnitude? It suggests that you are not a small, singular entity trapped in a cage of bone. It suggests that you are a multidimensional being, a creature that spans the breadth of the quantum multiverse. The you that you experience right now is just one facet of a much larger diamond. You are a cross-section of a hyperdimensional object. Think about the regrets we started with, the path not taken. In the many worlds view, there is no such thing as a path not taken. You took it. Another version of you walked down that road, fell in love with that person, lived in that city. The pain of regret comes from the illusion of scarcity. It comes from the belief that you missed out. But you didn't miss out. You just branched off. The experience exists. It is being felt right now by a consciousness that shares your origin, shares your name, shares your history up until the moment of the split. There is a profound, if somewhat terrifying, comfort in this. It means that every tragedy is balanced by a triumph. In the universes where you failed, there are universes where you succeeded. In the universes where you lost a loved one, there are universes where you are still holding their hand. In the universes where humanity destroys itself, there are universes where we reach the stars. The multiverse is a place of total completeness. Everything that can happen does happen. But this also raises a deeply unsettling question about death. There is a famous thought experiment called quantum suicide, or, more gently, subjective immortality. Imagine a physicist sitting in a box with a device that has a 50-50 chance of killing them instantly, based on the decay of a radioactive atom. In the Copenhagen view, after the experiment, the physicist is either dead or alive. But in the many worlds view, the universe splits. In one branch, the device fires and the physicist dies. In the other branch, the device clicks and nothing happens. And the physicist lives. From the perspective of the outside world, the physicist eventually dies in many branches. But from the perspective of the physicist, The consciousness cannot experience its own non-existence. The consciousness only continues in the branches where the brain is still functioning. So, in every single split, the physicist finds themselves in the branch where they survived. To the physicist, the gun just keeps jamming. Click, click, click. They perceive a miraculous, impossible string of luck. They effectively become immortal in their own subjective timeline. Watching the universes where they die peel away like dead skin. Could this be what happens to us? Do we simply slide along the branches of the multiverse that sustain our consciousness, surviving accidents and illnesses against all odds, until we reach the absolute physical limits of biology? Is your consciousness a thread that navigates the labyrinth of death, always finding the open door? It is a dizzying thought. It makes the room spin. But let us ground ourselves again. If we are living in a multiverse of infinite splitting, why does it feel so singular? Why does it feel so solid? Why does the coffee cup feel heavy in your hand? And why does the silence of the room feel so unique? The answer lies in the concept of decoherence. The environment, the air molecules, the photons of light, the gravity, is constantly measuring us. It is constantly entangling with us. This constant interaction effectively seals off the other branches. It makes the walls between the worlds thick and impenetrable. We are locked into our track by the sheer complexity of our interactions with the world, but perhaps not entirely locked. There are some physicists and many mystics who wonder if the boundaries are absolute. If consciousness is the fundamental stuff of the universe, as we suspected in the first chapter, and if the multiverse is the structure of that consciousness, perhaps there are moments where the walls thin, perhaps intuition or déjà vu or the strange sense of synchronicity is a momentary resonance with a nearby branch. Perhaps when you have a sudden, brilliant idea, it is a leak from a version of you who had already thought of it in a neighboring universe. Perhaps the feeling of the ghost inside you is actually the collective resonance of all your quantum selves. Maybe the self is not a point, but a cloud. Maybe the weight of your being is the weight of infinite variations of you, all stacked on top of each other, humming in harmony. This changes the way we look at other people too. When you look at a stranger, you're seeing only one version of them. You're seeing the version that exists in this specific slice of reality. But lurking behind their eyes are infinite other versions, heroes, villains, lovers, strangers. You are interacting with a quantum probability cloud that has momentarily condensed into a person, and it changes the way we look at our own choices. If every choice creates a new universe, then every choice is an act of creation. You are not just navigating a pre-existing world. You are constantly birthing new worlds. You are a universe generator. The responsibility is immense, but so is the freedom. You are carving your specific path through the diamond of the infinite. You are creating a unique story that exists nowhere else in the multiverse. As you lie in the dark tonight, let your mind expand to fill this space. Imagine the room you are in is just one of infinite rooms, stacked like the pages of a never-ending book. In the room next door, you turned off the light 5 minutes ago. In the room 10 pages down, you are reading a different book. In the room 1,000,000 pages away, you are living a life you can barely imagine. Feel the presence of these other selves. They are not enemies. They are not competitors. They are you. They are the chorus of your existence. You are never alone because you are infinite. But if the universe is this full, if it is this crowded with realities, where does the energy come from? How can nature afford to create entire new universes every fraction of a second? Is there an endless battery somewhere? Or is there a deeper field, a ground of being, from which all these possibilities spring? In the next chapter, we must dive to the very bottom of the ocean. We must go to the place where matter dissolves completely and only pure potential remains. We are going to explore the quantum vacuum, the zero-point field. We are going to see that empty space is not empty at all, but a seething, boiling cauldron of infinite energy. We are going to ask if this field is the source of consciousness, the ink with which the multiverse is written. We are going to ask if, at the deepest level, we are not the waves, but the ocean itself. Close your eyes. Feel the split. Feel the branches growing. And know that you are the gardener of eternity. In the quietest part of the night, when the noise of the day has finally retreated and the house settles into a profound stillness, try to focus on the space between things. Look at the empty air between your eyes and the wall. Look at the darkness that fills the corners of the room. We are trained by intuition and by language to think of this space as nothing. We think of it as a void, a passive stage, a mere container where the real actors, the atoms, the stars, the people, play out their dramas. We believe that if we could use a giant cosmic vacuum cleaner to suck out all the air, all the dust, all the photons of light, and all the radiation, we would be left with a perfect, silent zero, a state of absolute non-existence, a blank canvas with no paint. But what if I told you that this intuition is the greatest illusion of all? What if I told you that the empty space in front of your nose is not empty, but is actually the most dense, the most powerful, and the most alive thing in the universe? What if the nothing is actually a hidden everything, a seething, boiling ocean of infinite energy that connects all things, records all memories, and perhaps even generates the spark of your own consciousness? Welcome to the deepest level of reality we have ever discovered. We have journeyed through the illusion of solid matter, the mystery of the observer, the ghostly threads of entanglement, and the branching paths of the multiverse. Now, we must dive beneath the waves. We must descend into the quantum vacuum, also known as the zero-point field. We are going to explore the possibility that you are not a solid object moving through empty space, but a ripple moving through a sea of light. To understand the vacuum, we have to go back to the fundamental rule of quantum mechanics that we touched on earlier, the Heisenberg uncertainty principle. Most people know this as the rule that says you cannot know the position and speed of a particle at the same time. The more you know one, the less you know the other. Nature refuses to be pinned down. But there is another version of this rule, one that applies to energy and time. It says that you cannot know the precise energy of a system over a very short period of time. This sounds like a technicality, but it has a mind-blowing consequence. It means that zero energy is impossible. Zero is a precise number. Zero is a fixed state. If a patch of space had exactly zero energy, we would know its energy perfectly zero, and its rate of change perfectly zero. The uncertainty principle forbids this. Nature abhors a vacuum, not just in the old Aristotelian sense, but in a deep quantum sense. Nature abhors stillness. So, what happens in the dark? In that cubic centimeter of empty space before your eyes, a chaotic, violent, and beautiful dance is happening at a speed that makes nanoseconds look like eons. Virtual particles, ghostly pairs of matter and antimatter, are popping into existence out of nowhere. They borrow energy from the vacuum, live for a fraction of a second, and then collide and annihilate each other, returning their energy to the field. Pop, flash, gone. Pop, flash, gone. This is happening trillions of times a second, everywhere, in every single pore of your skin, in every vast stretch of intergalactic void. The silence is not silent. It is a roar of creation and destruction so fast that our senses smooth it out into a flat, quiet nothingness. Physicists call this the quantum foam. Imagine looking at the ocean from a satellite in orbit. It looks like a smooth blue sheet of glass. It looks peaceful. It looks empty of motion. But if you zoom in, down to the surface, you see 20-foot waves crashing, whitecaps foaming, currents swirling. The stillness is an illusion of scale. The reality is turbulence. But how much energy is in this turbulence? This is where the numbers become so large that they break the human imagination. When physicists like John Wheeler and Richard Feynman tried to calculate the energy density of the quantum vacuum, the amount of energy contained in the background of space, they came up with a number that is famously embarrassing to cosmology, but spiritually electrifying. They calculated that the energy contained in a single coffee cup of empty space is enough to boil all the oceans of the world instantly. In fact, it is much more than that. The Planck density of the vacuum suggests that every cubic centimeter of space contains more energy than all the matter in the observable universe combined. Let that sink in. You are not running on a battery. You are not powered by the sandwich you ate for lunch. Those are just tiny chemical adjustments on the surface. At the fundamental level, you're floating in a sea of infinite power. You're like a fish swimming in water, unaware of the water, because it is everywhere. You only see the bubbles. You only see the matter. But the matter is just a tiny, tiny excitation of the field. Matter is just a place where the vacuum has thickened. This is a radical inversion of who we think we are. We usually think that matter is the real stuff, and space is the nothing. But the zero-point field suggests that space is the real stuff, the plenum, the fullness, and matter is just a rarefied, fluffy disturbance within it. You are not a solid thing. You are a localized vibration in the field of the absolute. So, why don't we feel it? Why don't we burn up? Why doesn't the sheer weight of this energy crush us into a black hole? This is one of the greatest unsolved mysteries in physics, known as the cosmological constant problem. But the answer might be simple. We don't feel it because we are it. We are made of the same stuff. A wave does not feel the weight of the ocean. It is an expression of the ocean. But let us bring this back to consciousness. Let us bring this back to the ghost in the machine. If the universe is filled with this background field of infinite energy and potential, could this field be the medium of consciousness? Could the zero-point field be the hard drive of the cosmos? There are scientists and philosophers who believe that the vacuum is not just energetic, but distinctively informational. Think about the virtual particles. They are constantly interacting with the real particles of your body. Every electron in your atoms is constantly dancing with the vacuum, exchanging energy, feeling the force of the empty space. This is not just theory. We can measure it. We call it the Lamb shift. We can see it in the Casimir effect, where two metal plates are pushed together by the pressure of the vacuum itself. The nothingness pushes back. If every particle is interacting with the field, then the field technically knows the state of every particle. It contains the imprint of everything that has ever happened. It holds the memory of the light that left the first stars. It holds the memory of the configuration of your brain. when you fell in love. It holds the pattern of every thought, every dream, every heartbeat. Some have compared this to the ancient concept of the Akashic records, a cosmic library where every event is written on the ether. But we don't need mysticism to see the parallel. We just need quantum field theory. If information cannot be destroyed, a core tenet of quantum mechanics, then where does it go? It goes into the field. It goes into the vacuum. Ervin Laszlo, a philosopher of science, calls this the Akashic field. He suggests that the brain is not just interacting with the local electric signals of the neurons, but is constantly reading and writing to the zero-point field. This would explain the non-local connections we discussed in the chapter on entanglement. If we are all excitations of the same field, then we are not separate. We are just different peaks of the same wave. When you communicate with someone, you are not sending a signal across a void. You are plucking the web that connects you both. This idea of a universal field of consciousness offers a profound answer to the hard problem. Consciousness is not produced by the brain. Consciousness is the vacuum. The vacuum is a field of pure subjectivity, pure awareness, pure potentiality. When this potentiality organizes itself into a complex system like a brain, it becomes a person. It becomes a localized point of view. Imagine a whirlpool in a river. The whirlpool has a definite shape. It has a location. It has a name. You can point to it and say, there is the whirlpool. But what is the whirlpool made of? It is made of water. If you take the water away, the whirlpool disappears, but the water remains. The whirlpool is just a way the water behaves for a while. You are a whirlpool in the zero-point field. Your body, your memories, your personality, these are the structure of the vortex. They are the pattern of the flow. But the substance of you, the thing that is actually looking out of your eyes, is the field itself. It is the eternal, infinite, energetic void. This is why deep meditation often feels like returning home. When you quiet the mind, when you stop the whirlpool of thoughts, you settle back into the stillness of the water. You stop identifying with the pattern and start identifying with the substance. You feel the peace of the vacuum. You feel the presence of the infinite energy that sustains you. This perspective also changes our relationship with death. If you are the whirlpool, then death is simply the water slowing down and flowing back into the main current. The pattern dissolves. Yes, the specific configuration of memories and habits that you call John or Sarah might loosen and fade. But the stuff of you, the consciousness, the awareness, the energy, cannot be destroyed. It just returns to the potential. It returns to the ocean. And because the vacuum is holographic, meaning the whole is contained in every part, perhaps the information of your life is never lost. Perhaps every thought you have ever had is written permanently into the fabric of space-time, a standing wave in the eternal now. Let us try a visualization to help you feel this. Close your eyes for a moment. Imagine your body. Feel the weight of your limbs. Now, imagine zooming in, past the skin, past the cells, past the molecules. See the atoms, vast and empty. Now, zoom into the space between the electrons. See that space not as dark, but as a blindingly bright, shimmering web of light. See it vibrating with infinite power. Feel that this light is inside you. It is the core of your being. Now, imagine that this light extends out of your body, through the walls of the room, through the atmosphere, out into the cosmos. There is no break. There is no edge where you stop and space begins. It is all one continuous field of energy. You are continuous with the sun. You are continuous with the black holes at the center of the galaxy. You are continuous with the person sleeping in the room next to you. The separation is a trick of the senses. The unity is the physics of the reality. This understanding can be a source of immense strength. When you feel drained, when you feel small, when you feel powerless, remember the teacup. Remember that you have enough energy within you to boil the oceans. You're not lacking. You're not empty. You are made of the fire of creation. The quantum vacuum also suggests a mechanism for how thoughts might become reality. We often hear about manifesting or the law of attraction, and usually these are dismissed as wishful thinking. But in the context of the zero-point field, the idea gains a sliver of physical plausibility. If your brain is a quantum device interacting with the field, and if the field is the source of all matter, then perhaps a highly coherent thought, a strong, focused intention, creates a perturbation in the vacuum. Perhaps it creates a template, a blueprint, around which probability can collapse into reality. We are not just observers, we are broadcasters. We are constantly sending ripples into the vacuum. And because the vacuum connects everything, those ripples travel. They interact. They interfere. They create the interference patterns that we call circumstance or coincidence. As we drift toward the end of this chapter, let the feeling of the void shift in your mind. Do not fear the dark. The dark is not empty. The dark is the womb of the universe. It is the pregnant silence before the first word was spoken. It is the pause between the notes that makes the music possible. You are safe in this nothingness. You are held by it. You are it. But if we are made of this infinite field, and if our consciousness is a localized expression of it, what connects the biology of the brain to this cosmic physics? How does the wet, warm, messy machine of the head actually catch the signal of the vacuum? We hinted at microtubules earlier, but now we need to look at the theory that ties it all together. In the next chapter, we are going to explore the specific, controversial, and brilliant theory known as OR, Orchestrated Objective Reduction. We are going to look at the work of Sir Roger Penrose, a man who mapped the black holes, and Stuart Hameroff, a man who mapped the subconscious. We are going to ask if the human soul is actually a quantum geometric structure, playing a music that the universe can hear. We are going to see if we can find the exact point where the ghost enters the machine. Rest now. Let your thoughts dissolve into the foam. Let your individual wave settle back into the ocean. You are the silence. You are the space. You are the light. In the silence of the night, if you listen closely enough, you can almost hear the hum of your own existence. It is a low, steady rhythm, deeper than the beat of your heart, deeper than the flow of your breath. It is the sound of your mind being woven together moment by moment from the raw fabric of the universe. In the previous chapters, we have traveled far. We have seen that matter is mostly empty space. We have seen that particles can be in two places at once. We have seen that the future can rewrite the past and that the universe might be a vast branching multiverse of infinite possibility. We have even dipped our toes into the zero-point field, that seething ocean of energy that connects all things. But a nagging question remains, a question that skeptics and materialists have used for decades to try and shut the door on the quantum mind. They ask, how? How does the delicate, freezing, fragile magic of quantum mechanics survive inside the warm, wet, noisy swamp of the human brain? We know that quantum states are incredibly sensitive. A single stray atom, a single vibration of heat, usually destroys the superposition instantly. It is called decoherence. To build a quantum computer in a lab, we have to cool it down to near absolute zero and shield it in a vacuum. Your brain is 37 degrees Celsius. It is a chaotic storm of fluids and salts. According to standard physics, any quantum state inside your head should vanish in less than a trillionth of a second, far too fast to affect your thoughts. But tonight, we are going to explore a theory that challenges this assumption. We are going to look at the work of two maverick geniuses who believe they have found the secret hiding place of the soul. We are going to explore the theory of orchestrated objective reduction, or OR, and we are going to discover that inside your neurons there is a biological technology so advanced, so perfect, and so beautiful that it turns the noisy swamp of the brain into a crystal cathedral of quantum resonance. Our story begins with a physicist and an anesthesiologist. The physicist is Sir Roger Penrose, a man who spent his life mapping the geometry of black holes and the structure of the universe. He looked at the human mind and realized something profound. Thinking is not just computation. A computer follows rules. It follows an algorithm. If A happens, do B. But human consciousness has something else. It has understanding. It has insight. It has the ability to see truth in a way that cannot be proven by a step-by-step logical process. Penrose used a famous mathematical proof called Gödel's incompleteness theorem to argue that the human mind is non-computable. We are not just biological calculators. We are accessing something outside the system of logic. We are accessing a fundamental truth of the universe. The anesthesiologist is Stuart Hameroff. For 30 years, he spent his days putting people to sleep. He watched as a gas was breathed into the lungs, and the lights of consciousness went out. The brain was still active. The neurons were still firing. The heart was still beating. But the person was gone. Hameroff wanted to know exactly what did the gas turn off. It didn't turn off the electricity. It turned off the magic. He began to look deep inside the neuron, past the membrane, past the nucleus, into the cytoskeleton, the skeleton of the cell. Most biologists thought the cytoskeleton was just scaffolding, like the bones in your body, there to hold the cell's shape. But Hameroff saw something else. He saw a lattice. He saw a crystal structure made of tiny proteins called tubulins, arranged in perfect spiral cylinders called microtubules. These microtubules are everywhere. They are the highways of the cell. They are the structures that pull chromosomes apart when cells divide. And, most importantly, they are incredibly abundant in the neurons of the brain. Hameroff looked at the structure of these microtubules and saw a computer, but not a normal computer. The tubulin proteins were arranged in a pattern that looked suspiciously like the logic gates of a digital machine, but they were also arranged in a Fibonacci spiral, a sacred geometric pattern found throughout nature, from pine cones to galaxies. He wondered, could these crystal tubes be the place where the quantum magic happens? When Penrose and Hameroff met, the pieces of the puzzle clicked together. Penrose had the theory of why consciousness must be quantum, because it connects to the non-computable geometry of space-time. Hameroff had the biological structure, the microtubule, that could act as the device. Together, they proposed something radical. They suggested that the microtubules are not just structural supports. They are quantum antennas. They act as waveguides for quantum states. Inside the hollow core of the microtubule, shielded by a special kind of gel that protects against the noise of the brain, the tubulin proteins can enter a state of superposition. They can be in two states at once. They can be on and off simultaneously. Imagine a single neuron. Inside it, there are millions of these microtubules. Inside each microtubule, there are millions of tubulin proteins. If they all enter superposition together, if they all start vibrating in quantum harmony, they create a massive, coherent quantum wave. This wave spreads through the neuron, then jumps across the synapses to other neurons, creating a macroscopic quantum state that spans large areas of the brain. But a wave of possibility is not a thought. A thought is a specific thing. You think apple, not every fruit in the universe. The wave has to collapse. This is where Penrose's genius comes in. He proposed a new way of understanding the collapse of the wave function, which he called objective reduction. In the standard view, the collapse happens when you measure it. But Penrose said no, the collapse happens because of gravity. Think about it this way. Einstein taught us that mass curves space-time. If a particle is in one location, it creates a tiny dimple in the fabric of the universe. If a particle is in superposition, if it is in two places at once, it creates two dimples at the same time. It separates the fabric of reality into two slightly different versions. It creates a blister in space-time. Nature does not like blisters. It is unstable. The universe wants to resolve the separation. The more mass involved, the more unstable it becomes. Penrose calculated that when the superposition gets big enough, when enough tubulins in the brain are involved, the difference in space-time curvature reaches a critical threshold. The blister pops. The universe snaps back into a single shape. And that snap, that moment of self-collapse, is a moment of consciousness. It is a bing of awareness, a tiny elementary spark of experience. In the Orchestrated theory, your stream of consciousness is actually a sequence of these tiny snaps, happening roughly 40 times a second. This frequency, 40 hertz, matches exactly the frequency of gamma waves in the brain, which neuroscientists have long known are associated with moments of intense focus and insight. You are not a continuous film. You are a series of quantum frames, discrete moments of creation, where the universe decides on a specific geometry of reality. Why is this called orchestrated objective reduction? Because the microtubules are not just letting the collapse happen randomly. They are tuning it. They are organizing the quantum state, the biology of the brain, the inputs from your senses, the memories stored in the synaptic connections. All of these act as the orchestra, guiding the quantum wave toward a specific collapse. The brain provides the inputs, the quantum vacuum provides the potential, and the collapse provides the experience. This theory is breathtaking because it connects three different worlds. It connects the biological world of the brain, the quantum world of the atom, and the relativistic world of space-time geometry. It says that consciousness is not an accidental byproduct of evolution. It says that consciousness is intrinsic to the structure of the universe. The proto-conscious moments are built into the very fabric of reality, into the Planck scale geometry of space-time itself. Your brain is just a machine evolved to amplify and organize these fundamental sparks into a rich, coherent human life. Think about what this means for you. It means that when you have a thought, you are literally reshaping the geometry of the universe. You're taking a superposition of space-time curvatures, a multitude of possible realities, and selecting one. You are a sculptor of space and time. This also explains why we feel a connection to the Platonic world of mathematics and beauty. Penrose believes that these Platonic values, truth, beauty, justice, are actually embedded in the fine structure of the universe. When our minds resonate with the quantum level, we are accessing this hidden realm. We are touching the mind of God, or the fundamental code of the cosmos. When you hear a piece of music that makes you cry, or see a mathematical equation that feels right, you are not just having a chemical reaction. You are aligning your personal quantum state with the universal geometry. And what about anesthesia? Hameroff's research suggests that anesthetic gases work by binding to the exact spots on the tubulin proteins where the quantum vibrations happen. They don't kill the cell. They don't stop the electrical signals. They just dampen the quantum vibration. They prevent the superposition from reaching the critical threshold. The bing never happens. The music stops. The instrument is still there. The brain is intact. But the player has been silenced. This implies that consciousness is a delicate, resonating song being played on the strings of the universe. But there is an even deeper implication, one that leads us to the edge of what we consider life and death. If the quantum information in the microtubules is not destroyed when it collapses, but merely reorganized, what happens when the biology fails? What happens when the heart stops and the blood stops flowing and the microtubules lose their coherence? In a classical computer, if you smash the hard drive, the data is gone. But quantum information cannot be destroyed. It can only leak. Hameroff has suggested that when the brain dies, the quantum information that made up your mind doesn't vanish. It decoheres back into the larger field. It leaks out of the microtubules and returns to the zero-point field, the quantum vacuum we discussed in the last chapter. The specific pattern of you dissolves into the general ocean of consciousness. But if the quantum state was highly coherent, could it hold together for a while without the body? Could the soul exist as a bubble of quantum information floating in the universe? This brings us to the phenomenon of near-death experiences. Millions of people have reported floating above their bodies, seeing a tunnel of light, feeling a sense of infinite love and connection. Skeptics dismiss these as hallucinations of a dying brain. But in the context of Orco-R, there is another possibility. Perhaps, for a few moments, the quantum soul has been released from the confinement of the microtubules, but has not yet dissolved. Perhaps it is expanding into the non-local universe, experiencing the entanglement with all things that is usually filtered out by the brain. When people are resuscitated, they often say they were yanked back into their bodies. Hameroff suggests this is the quantum information being recaptured by the microtubules as they warm up and regain coherence. The ghost is pulled back into the machine. This theory transforms the brain from a generator of consciousness into a receiver of it. It is a reducing valve. The universe is too loud, too bright, too full of information for us to handle. If we experienced the full quantum reality all the time, we would be overwhelmed. We wouldn't be able to tie our shoes or find food. The brain's job is to filter out the infinite and give us a small, manageable trickle of here and now. But the filter is not the source. As you sit in the quiet of your room, visualize the trillions of microtubules inside your head. See them as tiny crystalline flutes. Imagine the breath of the universe blowing through them, creating the music that is you. Every thought is a note. Every feeling is a chord. You are a symphony of space-time geometry, playing a song that has never been played before. The skeptics will say, it is too good to be true. They will say, the brain is too warm, too wet. But recent experiments are starting to prove them wrong. We have found quantum vibrations in plant photosynthesis. We have found quantum compasses in the eyes of birds. The warm, wet, and noisy argument is crumbling. Life, it seems, learned to master the quantum world billions of years ago. You are a quantum being. You are a creature of light and geometry, masquerading as a creature of flesh and blood. But if our consciousness can exist outside the body, if it is fundamentally non-local, then what limits us? Why do we feel so small? Is it possible to expand the bandwidth of the receiver? Is it possible to tune the radio to other stations? In the next chapter, we are going to explore the limits of human potential. We are going to look at the phenomenon of sati, telepathy, precognition, remote viewing. We are going to ask if these paranormal abilities are actually just normal functions of a non-local quantum mind that we have forgotten how to use. We are going to see if the entanglement we share with others can be used to send messages across the silence. The walls of your room are solid, but your mind is not. The cage is open. The bird is ready to fly. In the stillness of the night, have you ever felt the sudden, undeniable weight of someone's gaze on the back of your neck? You turn around and sure enough, across the crowded room or the empty street, someone is looking at you. Or perhaps you have reached for the phone to call a friend you haven't spoken to in months, only to have it ring in your hand the moment your fingers touch the screen, and it is them on the line. We have all experienced these moments. We call them coincidences. We call them luck. We laugh them off because our rational minds, trained in the hard logic of a mechanical world, have no shelf to put them on. We are taught that thoughts are private things, locked inside the bone vault of the skull, invisible and silent to everyone but ourselves. We are taught that to communicate, we must speak or type or gesture. We are taught that the mind stops at the skin. But tonight, we are going to challenge that boundary. We are going to take the principles we have learned, non-locality, entanglement, the zero-point field, and ask if they apply not just to subatomic particles, but to us. We are going to explore the forbidden territory of science, the realm of psi, telepathy, clairvoyance, precognition. These are words that usually belong to folklore and fantasy, not to the laboratory. But if the brain is indeed a quantum instrument, as we discovered in the last chapter, then these abilities are not supernatural. They are supernatural. They are simply the natural functioning of a consciousness that is not confined to a single point in space or time. Let us begin with the concept of connection. In the chapter on entanglement, we saw that two particles, once linked, remain linked forever, dancing in unison across the width of the galaxy. If your brain is made of particles that have been interacting with other particles since the Big Bang, and if your mind is a quantum field generated by the microtubules in your neurons, is it so hard to believe that your mind could be entangled with another mind? Imagine two people who love each other deeply, a mother and her child, identical twins, two lovers who have spent decades sleeping side by side. Their brains have been in constant interaction. Their electromagnetic fields have washed over each other. Their quantum states have resonated. Is it possible that they have formed a macroscopic entanglement? Science is beginning to say yes. There are experiments, rigorous and repeated, that suggest this connection is real. In one famous study, two people are meditated together to create a bond, and then they are separated into different rooms, shielded by steel and copper to block any electromagnetic signals. One person is shown a flashing light that stimulates their visual cortex. The other person sits in the dark, seeing nothing. But when the light flashes for the first person, the brain of the second person, the isolated one, often shows a spike in activity at the exact same moment. It is a whisper across the void. It is the brain acting not as a generator of private thoughts, but as a receiver of shared consciousness. This phenomenon, often called telepathy, is simply the biological expression of quantum non-locality. It suggests that, at a deep level, beneath the noise of our individual egos, our minds are touching. The ocean of the zero-point field is not just a storage device, it is a conductive medium. When you think a thought, you are dropping a stone into that ocean. The ripples travel, and if another mind is tuned to your frequency, through love, through shared history, or through simple focus, they can feel the wave. But the mind does not just travel to other minds. It seems to be able to travel to other places. In the 1970s and 80s, the U.S. government, specifically the CIA and the military, spent millions of dollars on a secret program called Stargate. They weren't looking for aliens. They were looking for psychic spies. They wanted to know if a human being, sitting in a quiet room in Maryland, could project their consciousness to a secret base in Siberia and describe what was there. The skeptics laughed. But the results were unsettling. The remote viewers, as they were called, were often ordinary people. They were given nothing but a set of random coordinates, latitude and longitude. They would sit in a relaxed, meditative state, quiet their internal chatter, and simply describe the images that floated into their minds. "I see a crane," they might say. "I see a large body of water. I see a gray building with a dome." When the intelligence officers checked the coordinates, the descriptions were often startlingly accurate. They described submarines that hadn't been built yet. They described radar installations hidden in forests. They weren't right 100% of the time. The signal was often noisy, like a radio tuned slightly off station. But they were right far more often than chance could explain. How is this possible? If consciousness is produced by the brain, it should be stuck in the brain. But if consciousness is the fundamental field of the universe, and the brain is just a transceiver, then looking at a distant location is just a matter of tuning the dial. The information of the submarine in Siberia is present in the zero-point field. It is present everywhere, holographically. Your consciousness doesn't have to go there. It just has to access the information that is already here, in the vacuum of space, right in front of you. In the holographic universe, every point contains the whole. The coordinates are not a destination. They are an address in the cosmic library. This suggests that our sensation of being here, locked behind our eyes, looking out at a separate world, is a persistent illusion created by the brain's filtering mechanism. The filter is useful. It keeps us focused on finding food and avoiding tigers. But the filter is not the limit. When we relax, when we enter the hypnagogic state between waking and sleeping, the filter thins. The walls of the self become transparent. We start to see the things that are usually blocked out by the noise of survival. But if the mind can travel through space, can it also travel through time? This is perhaps the most challenging aspect of psi, but also the one with the strongest experimental evidence. It is called precognition, or future feeling. We have already seen in the chapter on the quantum eraser that the future can affect the past. We have seen that time is not a one-way street. Does our biology know this? There is an experiment famously conducted by researcher Dean Radin and others that suggests our bodies are constantly sensing the future. A person sits in front of a computer screen. They are hooked up to sensors that measure their heart rate, their skin conductance, sweat, and their blood volume. The computer waits for a few seconds, showing a blank screen. Then, it uses a random number generator to select an image. The image might be something calm, a flower, a basket of fruit, or it might be something emotionally intense, a snake, a car crash, an erotic scene. Here is the mystery. The sensors show that the person's body reacts before the image is shown. 2 or 3 seconds before the computer has even decided which image to pick, the heart rate goes up. The palms get sweaty, the pupils dilate. But only if the coming image is going to be intense. If the coming image is calm, the body stays calm. The body is reacting to an event that has not happened yet. The heart is beating for a future that is still in the realm of quantum probability. This is presentiment. It is the biological echo of a future event rippling backwards through time. It implies that our nervous system is not just reacting to the present moment. It is entangled with our future selves. The you of 3 seconds in the future, who sees the snake and feels fear, sends a ripple of that fear back along the timeline to the you of now. The wave function of your life extends in both directions. This gives a whole new meaning to gut instinct. When you have a bad feeling about getting on a plane, or a sudden urge to take a different route home, it might not be paranoia. It might be a memory from a future that you are trying to avoid. Your consciousness is navigating the branching paths of the many worlds, feeling the texture of the roads ahead, and steering you away from the cliffs. It suggests that intuition is a form of time travel. So, if we have these incredible abilities, if we are telepathic, clairvoyant, time-traveling quantum beings, why don't we experience this all the time? Why is it so hard to guess the lottery numbers? Why do we feel so separate? The answer lies in the signal-to-noise ratio. The signal of the non-local universe is subtle. It is a whisper in a hurricane. Our modern lives are loud. We are bombarded by sensory input, by social media, by the constant chatter of our own internal dialogue. The orchestrated objective reduction in our microtubules is mostly focused on maintaining the coherent illusion of the solid world. Evolution has tuned our brains to be robust, not sensitive. To survive on the savannah, you need to see the lion in front of you, not the lion in the next valley, or the lion that will be born next year. Psi is a weak force, much like gravity is a weak force compared to electromagnetism. Gravity holds the galaxies together, but a tiny magnet can pick up a paperclip against the pull of the entire Earth. Similarly, the non-local connection holds the universe of consciousness together, but the immediate demands of the ego, I am hungry, I am angry, I am late, overpower the subtle connection. However, the leak is always there. The filter is never perfect. Throughout history, shamans, mystics, and monks have developed technologies to quiet the noise. Meditation, fasting, chanting, drumming, sensory deprivation, all of these are methods to turn down the volume of the ego and turn up the sensitivity of the quantum antenna. They are methods to increase the coherence of the microtubules, to allow the non-local waves to wash through the brain without being scrambled. When a Zen master sits in silence for 20 years, they are not just relaxing. They are cleaning the lens. They are polishing the mirror of the mind so that it can reflect the moon of the absolute. And interestingly, quantum physics suggests that belief itself is a variable. In psi experiments, the sheep-goat effect is well documented. People who believe in the possibility of psi, the sheep, tend to score higher than chance. People who disbelieve, the goats, tend to score lower than chance, sometimes statistically significantly lower. which is a form of psi in itself, using precognition to actively avoid the right answer. This aligns with the observer effect. If you believe the world is solid and separate, your consciousness collapses the wave function into a solid, separate reality. You create the walls you are trapped in. If you believe the world is fluid and connected, you allow the entanglement to surface. You open the door. We are entering an era where the materialist view of the world is reaching its limit. We have mapped the genome. We have split the atom. We have landed on Mars. But we are lonelier and more anxious than ever. Perhaps it is because we have forgotten our powers. We have forgotten that we are not isolated fragments. Tonight, as you drift towards sleep, play with this idea. Imagine that your mind is not inside your head. Imagine it is a sphere of light that extends out to the walls of the room, to the house of your neighbor, to the stars above. Imagine that you can feel the dreams of the people sleeping in your city. Imagine that you are entangled with the person you will be tomorrow. Send a message to your future self. Send a feeling of love, of safety, of peace. Trust that the you of tomorrow will receive it. Trust that the you of yesterday is receiving the peace you feel right now. We are vast. We are limitless. We are the universe experiencing itself in a web of infinite connection. The paranormal is just the normal that we have not yet understood. But if our minds are connected, and if the universe is filled with a field of consciousness, does this field have a center? Is there a universal mind that contains us all? Is there a scientific basis for the concept of God, or Tao, or Brahman? In the next chapter, we are going to take the ultimate step. We are going to look at the theory of panpsychism and cosmopsychism. We are going to ask if the universe itself is a conscious entity. We are going to ask if the stuff of the cosmos is not matter, but mind. We are going to see if science and spirituality are finally ready to meet and shake hands in the light of the quantum dawn. The silence is listening to you, and you are listening to the silence. And in the deep dark, they are the same thing. In the deepest hour of the night, when the silence is so heavy, it feels like a blanket draped over the world. Try a simple experiment. Pick up an object. It could be a stone from the garden, a glass of water, or simply the wooden frame of your bed. Hold it in your hand. Feel its temperature. Feel its texture. Feel its weight pressing against your skin. We are taught from the moment we are born that this object is dead. We are taught that it is inanimate matter, a collection of frozen atoms held together by cold forces, devoid of feeling, devoid of awareness, devoid of any inner light. We look at the stone and we see a thing. We look at a dog and we see a friend. We look at another human and we see an equal. We draw a sharp, bright line across the universe, dividing the conscious from the unconscious, the who from the what. But tonight, in the quiet of our shared journey, we are going to erase that line. We are going to ask the question that has haunted mystics for millennia and is now returning to haunt the laboratories of our most advanced physicists. What if there is no dead matter? What if the universe is not a machine that somehow learned to think, but a mind that learned to build a machine? What if the stone in your hand is humming with a tiny, silent, primordial form of the very same awareness that is reading these words right now? Welcome to the concept of panpsychism. It is a word that comes from the Greek pan, meaning everything, and psyche, meaning mind. It is the radical, terrifying, and beautiful idea that consciousness is not a rare accident produced by the brain, but a fundamental property of the universe, as basic as mass, as ubiquitous as gravity, and as ancient as time itself. To understand why science is turning back to this ancient idea, we have to look at the failure of the standard story. Remember the hard problem we discussed in the first chapter? We asked how the wet, gray meat of the brain produces the Technicolor movie of your experience. We have tried to explain it with emergence. We say that if you put enough unconscious atoms together in a complex enough pattern, consciousness suddenly pops into existence, just like wetness pops into existence when you put enough water molecules together. But there is a flaw in this analogy. You can explain wetness. You can deduce the slippery, flowing qualities of water from the geometry of the H2O molecule. It makes sense. But you cannot deduce the feeling of love or the color red from the motion of an electron. There is a gap, a chasm. You can stare at the equation for a neuron firing for 1,000,000 years, and you will never find the sensation of a headache inside it. This has led thinkers like the neuroscientist Christoph Koch and the philosopher David Chalmers to a startling conclusion. Maybe we can't explain consciousness emerging from matter because it doesn't emerge. Maybe it was there all along. Think about the electron. We think we know what it is. Physics gives us a list of its properties. It has mass, it has charge, it has spin. But if you look closely, these are not descriptions of what the electron is. They are descriptions of what it does. Mass is just resistance to force. Charge is just interaction with electromagnetic fields. Physics describes the behavior of the particle. It describes the outside of the particle. But what is the electron on the inside? What is the intrinsic nature of the stuff that holds these properties? Materialism says there is nothing inside. It is empty. It is just a placeholder for math. But panpsychism suggests that the intrinsic nature of matter, the stuff that is doing the moving and the spinning, is consciousness itself. This does not mean that an electron is sitting there thinking about philosophy. It doesn't mean the stone is worrying about its future. That would be absurd. Human consciousness is complex because the human brain is complex. The electron's consciousness would be incredibly simple. It would be a tiny flicker of being, a microscopic spark of proto-experience, a vague sense of here-ness and spinness. But, and this is the crucial point, it is of the same kind as your consciousness. The difference between the electron's mind and your mind is a difference of degree, not a difference of kind. Just as a single photon is dim, but the sun is blinding, the electron is a dim spark of awareness. And you are a blazing star. If this is true, then the universe is not a dark, empty room with a few conscious lamps turned on in it. The universe is made of light. The lights are on everywhere. The vacuum of space, the burning heart of the sun, the cold dust of the asteroid belt. It is all shimmering with an internal life. But if every atom has a tiny mind, how do they combine to make your mind? How do 1 billion tiny micro-minds zip together to form one big macro-mind? This is called the combination problem. It is the biggest challenge to panpsychism. And the solution to this problem leads us to an even grander, more majestic idea. Perhaps we are looking at it backwards. Perhaps the universe didn't start as dust that woke up. Perhaps the universe started as a mind that shattered. This is the theory of Cosmopsychism. Imagine the Big Bang not as an explosion of matter, but as an explosion of awareness. In the beginning, there was a single, unified, infinite consciousness, a singularity of self. And when it expanded, it didn't lose that consciousness. It stretched it. It folded it. It dissociated. There is a psychiatric condition known as dissociative identity disorder, formerly multiple personality disorder, where a single human mind splits into several distinct alters. These alters can be completely separate. They can have their own memories, their own personalities, their own desires. They can even look in the mirror and not recognize each other. Yet, deep down, they are all processes running on the same underlying brain. They are ripples in the same pond. Bernardo Kastrup, a modern philosopher and computer scientist, suggests that the universe is exactly this. We are the alters of the cosmic mind. The universe is suffering from multiple personality disorder. In this view, your brain is not a generator of consciousness. It is not even a receiver of consciousness, as we discussed in the radio analogy. In Cosmopsychism, your brain is a boundary. Your brain is the mechanism of dissociation. It is a biological structure that evolved to wall off a tiny part of the infinite cosmic mind, to trap it in a skull, to make it forget that it is God, so that it can experience what it is like to be a finite, fragile, mortal human being. Think about the silence of the night again. That silence is the sound of the boundary. When you look into the eyes of another person, you're not looking at a stranger. You're looking at another alter of the same universal mind. You're looking at yourself, disguised. The hatred you feel for an enemy is the universe hating itself. The love you feel for a partner is the universe loving itself. The grief you feel is the universe missing itself. This resolves the combination problem because there is no combination. We don't have to glue atoms together to make a mind. The mind is the canvas. The atoms are just the brush strokes within it. This idea aligns beautifully with the quantum concepts we have explored. Entanglement is the memory of our original oneness. The zero-point field is the substrate of the universal mind. The collapse of the wave function is the universe making a choice. And it brings us to a startling interpretation of the Orch-OR theory we discussed. If the microtubules are quantum devices, maybe they are not creating consciousness. Maybe they are the valves that regulate the flow of the infinite mind into the finite vessel. Maybe they are the cracks in the wall of the ego where the light shines through. When the brain activity slows down in deep meditation, in the flow state, or under the influence of psychedelics, people often report a dissolution of the self. They report becoming one with the universe. Neuroscientists call this ego death and can see the default mode network of the brain shutting down. Under the materialist view, this is just a hallucination, a malfunction of the brain's circuitry. But under the Cosmopsychism view, this is the most sober moment of your life. It is the moment the dissociation fades. It is the moment the alter remembers the host. You are not losing your mind. You are finding the mind. You are realizing that the you who was born and will die is just a character in a dream, and the dreamer is eternal. Let us return to the stone in your hand. Hold it gently. If Cosmopsychism is true, that stone is a part of the same dissociation. It is a part of the universal mind that is held in a very rigid, very simple, very slow state of trance. It is consciousness sleeping a deep geologic sleep. It does not think in words. It does not feel emotions. It feels mass. It feels gravity. It feels the slow, crushing pressure of time. But it is there. The isness of the stone is the same as the isness of you. This changes everything about how we treat the natural world. We are not tourists on a dead rock. We are cells in a living body. The earth is not a resource. It is a relative. The Gaia hypothesis, the idea that the earth functions as a single living organism, becomes literal. We are the neurons of the planet. We are the way the Earth thinks. We are the way the universe reflects upon itself. As the great astronomer Carl Sagan said, we are a way for the cosmos to know itself. He didn't mean this metaphorically. He meant it literally. Without you, the universe is a blind giant. It has all the power, all the energy, all the potential, but it cannot see the beauty of a rose, or taste the sweetness of an orange, or feel the ache of a broken heart. It needs you for that. It needs your specific, limited, finite perspective to turn the raw energy of the quantum vacuum into the texture of experience. You are the sensory organ of the infinite. This brings a profound sense of responsibility. If you are the eyes of the universe, then what you choose to look at matters. If you are the heart of the universe, then what you choose to feel matters. When you focus on beauty, the universe experiences beauty. When you focus on cruelty, the universe experiences cruelty. You are not just living your life for yourself. You are living it on behalf of the whole. Imagine the freedom in this, the crushing weight of your individual anxiety, your fear of failure, your need to be special. It all begins to lighten. You don't have to be special. You just have to be. You are already the most special thing in existence, a localized aperture through which the Absolute is witnessing its own creation. The fear of death also transforms. If you are the universe, you cannot die. The wave crashes on the shore. Yes, the form of the wave is gone. But the water returns to the ocean. The dissociation ends. The amnesia lifts. You do not go into the dark. You wake up from the dream of being small. In the traditions of the East, this is called Tat Tvam Asi. Thou art that. You are that. You are the thing you have been looking for. You are the ghost, and you are the machine, and you are the space between them. But there is a trap here, a question that inevitably arises if we accept this view. If the universe is one single, infinite, powerful mind, why is it doing this? Why did it shatter itself? Why create a world of suffering, of separation, of pain? Why not just stay in the bliss of the eternal singularity? Is it bored? Is it lonely? Or is there a deeper purpose to this game of cosmic hide-and-seek? Is the universe evolving? Is it trying to learn something that it could not know in its state of perfection? In the next chapter, we are going to explore the meaning of it all. We are going to look at the theory of quantum evolution. We are going to ask if there is a direction to the cosmos. We are going to see if the universe is not just a static mind, but a growing child. We are going to ask if the struggle, the pain, and the beauty of your life are the fuel for a cosmic expansion of consciousness that goes far beyond the physical expansion of the galaxies. We are going to ask, what does the universe want with us? For now, sit with the stone. Sit with the silence. Feel the hum of the air, and know with a quiet, terrifying certainty that you are looking at yourself, and you are beautiful. In the darkest hours of the night, when the house is still, and the only movement is the slow, rhythmic breathing of your own chest, think for a moment about a seed buried deep in the cold earth of a winter garden. It lies there in the absolute dark, surrounded by the crushing weight of the soil, frozen in a state of suspended animation. To a casual observer, to a physicist measuring only its mass and its temperature, it appears to be a dead thing. It is just a capsule of chemistry, a tiny knot of carbon and water waiting to decay. But we know that inside that silence, something miraculous is waiting to happen. There is a blueprint, a set of instructions written in the ancient language of DNA. that knows how to take the chaotic, disordered dirt and sunlight and weave them into the intricate, symmetrical, living structure of a rose. Against all the odds of a universe that loves to break things down, the seed is plotting to build something up. It is plotting to create order out of chaos. It is plotting to create beauty out of mud. Tonight, we are going to expand this image until it fills the entire cosmos. We are going to ask if the universe itself is like that seed. We have spent the last few chapters looking at the what of consciousness, the quantum fields, the microtubules, the entangled webs. But now we must face the why. Poem. Why is the universe doing this? Why, in a cosmos governed by the second law of thermodynamics, a law that says everything should be cooling down, breaking apart, and drifting into a boring, uniform gray soup of entropy, has reality spent 13.8 billion years getting more complex, more organized, and more conscious? Welcome to the theory of quantum evolution. Welcome to the idea that the universe is not a static stage and not a random accident, but a learning machine, a growing organism, a child that is slowly, painfully, and beautifully waking up to its own potential. We are going to explore the possibility that your life, with all its struggles, its heartbreaks, and its moments of sudden clarity, is not a meaningless blip, but a vital piece of data in a cosmic experiment that has been running since the first moment of time. Let us begin with the problem of fine-tuning. This is the mystery that keeps cosmologists awake at night, staring at their chalkboards in disbelief. When physicists look at the fundamental constants of nature, the numbers that define the strength of gravity, the weight of the electron, the speed of light, the force that holds the atomic nucleus together, they find something unsettling. These numbers are perfect. They are balanced on a knife edge so sharp that it defies coincidence. If the force of gravity were just a tiny fraction stronger, the universe would have collapsed back into a black hole mere moments after the Big Bang. There would be no stars, no galaxies, no time for life to evolve. If gravity were a tiny fraction weaker, the matter would have flown apart so fast that stars would never have formed. The universe would be a cold, dark, empty gas. If the strong nuclear force were slightly different, carbon, the backbone of all life, would not be stable. If the electromagnetic force were slightly different, atoms could not bond to form molecules. It is as if the universe knew we were coming. It is as if, 14 billion years ago, someone sat down at a giant control panel and dialed every single knob to the exact, precise setting required to produce intelligent life. This is called the anthropic principle. It says that the universe must be compatible with the life that observes it. But why? There are two traditional answers. The first is luck. We just happened to win the cosmic lottery. The second is God. A creator designed it this way. But there is a third option, one that arises from the marriage of quantum mechanics and evolutionary biology. It is the idea that universes evolve. The physicist Lee Smolin proposed a theory called cosmological natural selection. It goes like this. We know that black holes are the most extreme objects in the universe. They are places where matter is crushed to infinite density. Smolin suggests that deep inside a black hole, the laws of physics break down and are reborn. A black hole is not a dead end. It is a seed. It is the womb of a baby universe. When a star collapses and forms a black hole, it triggers a bounce, a new Big Bang that expands out into a separate dimension, creating a new universe. But here is the twist. This new baby universe inherits the DNA, the physical laws of its parent universe, but with tiny, random mutations. Maybe gravity is a little stronger. Maybe the electron is a little lighter. Now, apply Darwin's logic. Which universes will survive and reproduce? The ones that are good at making black holes. And what does a universe need to make black holes? It needs stars. It needs gravity. It needs stable atoms. It needs exactly the kind of complex, fine-tuned physics that we see around us. And here is the beautiful coincidence. The same conditions that are perfect for making black holes are also perfect for making life. Carbon, stars, stable chemistry, these are the prerequisites for both. So, we live in a bio-friendly universe, not because it was designed for us, but because life is a parasite on the universe's reproductive system. We are the mold growing on the egg of a black hole. But this theory, while elegant, is missing something. It explains the stars, but it does not explain the mind. It does not explain why the universe needs to be aware. To solve that, we have to turn to the visionary physicist John Wheeler again, the man who gave us the participatory universe. He coined a phrase that might be the most important 3 words in modern physics. It from bit. It, the physical world, the atom, the rock, the star, comes from bit, information. Wheeler suggested that the fundamental stuff of the universe is not matter and not energy, but information. Yes, no, up, down, 0, 1. The universe is asking binary questions of itself. Every time a particle interacts, every time a wave function collapses, a bit of information is processed. In this view, the universe is a giant computer. But what is it computing? It is computing itself. It is computing the future. Imagine a neural network like the artificial intelligence systems we are building today. An AI starts with no knowledge. It makes mistakes. It tries random things. But every time it gets a reward, every time it solves a problem, it strengthens the connections that worked. It learns. It evolves. It moves from chaos to order. Perhaps the universe is a self-learning quantum neural network. In the beginning, near the Big Bang, the network was simple. The questions were simple. Hot or cold? Fast or slow? But as the universe cooled and expanded, it began to crave more complexity. It began to crave novelty. The philosopher Alfred North Whitehead suggested that the driving force of the universe is the creative advance into novelty. The universe gets bored. It wants to create new forms. It wants to surprise itself. It creates stars, but stars are just burning balls of gas. They are repetitive. So it creates planets. Planets are more complex, but they are still just rocks. So it creates chemistry. Chemistry is dynamic, but it is blind. So the universe takes the ultimate leap. It creates life, and then it creates mind. Why? Because a conscious mind is the ultimate generator of novelty. A star will burn the same way for 10 billion years. But a human mind? In a single day, a human mind can imagine a poem, design a machine, feel a heartbreak, and contemplate the infinite. A human mind can create information that has never existed before in the history of time. This suggests that you are not just an observer. You are an agent of evolution. You are the universe's way of exploring the edge of possibility. Every time you have a new thought, every time you create something, every time you learn a new skill or overcome a fear, you're adding to the cosmic database. You're increasing the complexity of the whole. We can call this the omega point. This is a term coined by the Jesuit paleontologist Pierre Teilhard de Chardin. He believed that evolution is not a random walk, but a directional arrow. He believed that the universe is being pulled forward by a gravitational force of the future, a point of ultimate complexity and ultimate consciousness that he called omega. We are not being pushed from the past. We are being pulled by the future. We are falling toward God. Think about your own life in this light. Think about the struggles you face, the pain, the confusion. In a purely material universe, suffering is just bad luck. It is just neurons misfiring. But in a learning universe, suffering is data. Suffering is the friction of growth. It is the feeling of the universe stretching its capacity. When you solve a problem in your life, you are solving it for the universe. When you learn to forgive, you are teaching the universe how to forgive. When you learn to love, you are increasing the universe's capacity for love. This is the deep meaning of the holographic principle we discussed earlier. If you are a hologram of the whole, then your evolution is the whole's evolution. You cannot separate your spiritual growth from the cosmic expansion. There is a concept in systems theory called emergence. It describes how a higher level of order suddenly appears when the lower level gets complex enough. Life emerged from chemistry. Consciousness emerged from life. What is next? What is emerging from us? Perhaps we are the neurons of a budding global brain. With the internet, with our constant communication, with our shared empathy, we are knitting ourselves together into a higher order being. Maybe the singularity that futurists talk about is not machines taking over, but the human species finally waking up to its collective nature. Maybe we are about to become a single, conscious planet. And maybe, just maybe, this has happened before. If the universe is a multiverse, as the many worlds theory suggests, then perhaps there is a cosmic ecosystem. Perhaps universes that develop high levels of consciousness are the ones that survive in some metaphysical sense. Perhaps consciousness is the mechanism by which a universe stabilizes itself against the void. This brings us back to the feeling of the ghost. Why does it feel like there is something inside you that is watching, something that is ancient and calm? Maybe that watcher is the universe itself. There is a profound loneliness in the human experience. We feel separated from the world. We feel like strangers in a strange land. But this theory of quantum evolution tells us that the loneliness is a necessary illusion. It is the tension required for growth. If we felt perfectly one with everything all the time, we would dissolve. We would lose the friction that creates fire. We need the separation to create the relationship. We need the I and the you so that love can exist. Love is the force that bridges the gap. Love is the energy of reconnection. So, tonight, as you lay in the dark, feel the importance of your own existence. You're not a random accident. You're a probe sent by the infinite to explore the finite. You are a nerve ending of the cosmos sent to feel the texture of reality. Every tear you cry is the universe tasting its own salt. Every laugh is the universe delighting in its own joy. You are doing the work of eternity just by being human. But there is a shadow here, a question that lingers at the edge of this beautiful story. If we are the universe learning, and if our purpose is to gather data and grow, what happens when the probe breaks? What happens when the biological machine that holds your specific, unique perspective finally wears out and stops working? Does the data get uploaded? Does the learning persist? Or is the death of the body the end of the experiment? We have looked at the beginning of the universe. We have looked at the structure of the mind. We have looked at the purpose of life. Now, we must face the final frontier. We must look at the transition we call death. In the next chapter, we are going to explore the quantum soul. We are going to look at the theory that consciousness is not produced by the brain, but is transmitted by it, and therefore does not end when the transmission stops. We are going to look at the evidence for the survival of consciousness. We are going to ask, is death a wall, or is it a door? We are going to walk up to the edge of the abyss and look down, not with fear, but with curiosity. Because if energy cannot be destroyed, and if information cannot be lost, then the end is just a concept we invented. Rest now, little seed. The winter is long, but the spring is inevitable. The universe is dreaming of a rose, and that rose is you. In the deepest silence of the night, when the darkness seems to press against the windows and the world feels vast and indifferent, the human mind inevitably turns to its oldest and most persistent fear. It is a fear that has shadowed us since the first hominid looked at a fallen companion and realized they were not getting up. It is the fear of the end. We look at the flame of a candle, and when we blow it out, we see the smoke drift away, the light vanish, and the wick turn cold. Our intuition, forged in a world of physical objects that break and decay, tells us that we are like that candle. We believe that consciousness is a flame generated by the wax of the body, and when the body is spent, the flame simply ceases to be. We believe in the abyss. We believe that gone means nothing. We struggle to imagine non-existence, and yet we are terrified by the certainty of it. We build our lives, our cities, and our philosophies as fortresses against this inevitable fading. But tonight, we are going to walk directly toward that fear. We are going to take the lamp of quantum mechanics and shine it into the abyss. And what we might find there is not a wall and not an empty void, but a door. We are going to explore the scientific possibility of the quantum soul. We are going to ask if the laws of physics, specifically the laws governing energy and information, actually forbid the destruction of who you are. We are going to explore the radical idea that death is not an ending, but a phase transition, a moment where the quantum information that makes up your mind is released from the confines of biology and returns to the infinite field from which it came. Let us start with the most bedrock principle in all of science, the first law of thermodynamics. It is a law that has never been violated in the history of physics. It states, quite simply, that energy cannot be created or destroyed. It can only change form. When a star dies, its energy does not vanish. It explodes outward, becoming light, heat, and heavy elements. When a log burns, its chemical energy becomes thermal energy and ash. The total amount of energy in the universe is constant. It is a closed system. Now, look at yourself. You are a swirling storm of energy. You are electrical impulses racing down neurons. You are chemical bonds breaking and reforming. You are the heat radiating from your skin. You are the electromagnetic field generated by your heart. If the first law holds true, and it must, then the energy that is currently animating your body cannot disappear when your body dies. It has to go somewhere. The materialist will argue, yes, the heat goes into the room and the chemical energy goes into the soil. But the pattern is lost. The energy survives, but the you is gone. They will say it is like smashing a Lego castle. The blocks are still there, but the castle is destroyed. But here is where quantum mechanics throws a wrench into the materialist machinery. In the quantum world, there is another law, perhaps even more fundamental than the conservation of energy. It is called the conservation of quantum information. This principle, known formally as the no-hiding theorem or the unitarity of quantum mechanics, states that information about a quantum system can never be destroyed. It can be scrambled. It can be encrypted. It can be spread out so thinly that it looks like random noise. But mathematically, If you have a powerful enough computer and you know the laws of physics, you should theoretically be able to take the radiation coming off a black hole and reconstruct the book that fell into it. The universe does not delete files. It only moves them to the cloud. If the OR theory we discussed in the previous chapter is correct, if your consciousness is a coherent quantum state existing in the geometry of space-time inside your microtubules, then your mind is quantum information. It is not just a Lego castle made of blocks. It is a specific, unique, resonant frequency of the universe. And according to the deepest laws of physics we know, that frequency cannot be silenced. It can only be retuned. Dr. Stuart Hameroff, the anesthesiologist, who co-created the OR theory with Sir Roger Penrose, has proposed a specific mechanism for what happens at the moment of death. Imagine the brain as a biological quantum computer. As long as the metabolism is running, the brain keeps the microtubules isolated, cold, and coherent. It holds the quantum state together, but when the heart stops, the blood stops flowing, the oxygen levels drop. The metabolic energy required to maintain the isolation fails. At this moment, the quantum coherence in the microtubules begins to break down. The blister in space-time that constitutes your conscious experience can no longer be contained within the geometry of the cells. But Hameroff suggests that the quantum information doesn't just poof out of existence. Instead, it leaks. It decoheres from the neurons and entangles with the larger environment. It flows out of the brain and into the zero-point field, the Planck scale geometry of the universe itself. Hameroff puts it beautifully. When the heart stops, the microtubules lose their quantum state. The quantum information within the microtubules is not destroyed. It can't be destroyed. And it just distributes and dissipates to the universe at large. In this view, the soul is not a religious concept. It is a physical concept. It is a packet of ultra-dense quantum information that has been organized by a lifetime of experiences, thoughts, and loves. When the biological receiver breaks, the signal doesn't stop. It just expands. It goes from being local in your head to being non-local everywhere. This provides a startlingly scientific framework for understanding near-death experiences, NDEs. For decades, millions of people who have technically died, whose hearts stopped, whose brain activity went flat, have reported the same sequence of events. They report floating out of their bodies. They report seeing the room from above. They report moving through a tunnel toward a brilliant, loving light. They report a life review, where they relive every moment of their lives in an instant. Skeptics call these hallucinations caused by a dying brain starved of oxygen. But there are problems with the hallucination theory. First, these experiences often happen when the brain has no measurable electrical activity. A flatlined brain shouldn't be able to hallucinate a complex, hyper-real narrative. Second, the experiences are hyper-lucid. People report that the dream felt more real than reality. And third, there is the phenomenon of veridical perception, where people floating above their bodies see and hear things in the hospital room that they couldn't possibly have known, which are later confirmed by the doctors. If we apply the quantum soul theory, the NDE makes perfect sense. When the quantum state leaks out of the microtubules, it is no longer anchored to the specific coordinates of the eyes and ears. It becomes non-local. It is suddenly entangled with the room, with the sky, with the universe. The floating sensation is the consciousness releasing its grip on a specific point in space. The tunnel might be the subjective experience of moving through the scales of space-time, diving deeper into the quantum vacuum. And the light? What is that overwhelming, loving light that everyone sees? Perhaps it is the zero-point field itself. Perhaps it is the raw energy of the cosmos, the ground of being that we discussed in Chapter 5. When the filter of the ego is removed, when the brain stops reducing the infinite down to the finite, we are suddenly confronted with the full, blinding luminosity of the universe. We are meeting the source, and because the source is the unity of all things, we experience it as love, because love is just the felt experience of connection. The life review is equally fascinating through a quantum lens. People don't just remember their lives, they relive them, and often they report feeling the events not just from their own perspective, but from the perspective of the people they affected. They feel the pain they caused others. They feel the joy they gave others. Why? Because in the non-local field, everything is entangled. The separation between me and you was a biological illusion. Once you're out of the body, you have access to the full holographic record. You are entangled with the people you interacted with. Their experience is recorded in the same field as yours. The life review is simply the consciousness accessing the Akashic data of its own trajectory through the web of entanglement. This suggests that judgment is not something imposed by a god on a throne. It is a law of physics. It is the inevitable confrontation with the truth of your own entanglement. You judge yourself because, in that state, you finally feel the reality of what you were to the world. But does this quantum soul persist forever? Or does it eventually dissolve into the ocean like a drop of water, losing its identity? This is where the mystery deepens. Some theories suggest that if the quantum information is coherent enough, if the soul has developed a strong enough pattern, it can hold together. It can exist as a soliton, a self-reinforcing wave bundle in the field. It might be able to drift through the cosmos, a ghost of memory and intent, looking for a new anchor. This brings us to the controversial, but scientifically intriguing possibility of reincarnation. If consciousness is a download from the cloud to the brain, can the cloud download the same file to a new device? Dr. Ian Stevenson, a psychiatrist at the University of Virginia, spent 40 years documenting thousands of cases of children who spontaneously remembered past lives. These weren't vague stories. They were specific. Children would give names, dates, and locations of people they had never met, often in distant towns. When researchers investigated, they found that these people actually existed and died exactly as the children described. In a materialist worldview, this is impossible. In a quantum worldview, it is merely a data transfer. If the information of a deceased personality is preserved in the holographic field, it is theoretically possible for a new, developing brain, a fresh quantum receiver, to tune into that specific frequency. It might be like a radio picking up an old broadcast that is still bouncing around the ionosphere. The child is entangled with the quantum soul of the deceased. This implies that we are part of a vast cosmic recycling system. The universe does not waste information, it composts it. It uses the lessons of the past to fertilize the future. Your life is not a one-off event. It is a chapter in a much longer book. Think about the comfort in this. The fear of death comes from the ego, which is terrified of losing its boundaries. But if physics is right, the boundaries were never real to begin with. You're already spread out across the universe. You're already ancient. The atoms in your hand were forged in stars that died billions of years ago. The information in your mind is entangled with the beginning of time. Death, then, is not a wall. It is a horizon. A horizon is not a real line. It is just the limit of our sight. When a ship sails over the horizon, it does not fall off the edge of the world. It just continues on a journey that we can no longer see from the shore. Dr. Robert Lanza, a proponent of biocentrism, argues that death is actually a reboot. He suggests that space and time are tools of the mind, not external realities. When the tool breaks, the mind doesn't end. It just steps out of the simulation. He says, death does not exist in a timeless, spaceless world. In the end, even Einstein admitted that the distinction between past, present, and future is only a stubbornly persistent illusion. So, tonight, as you lay in the dark, try to feel the part of you that is not afraid. There is a part of you that watches the fear, but is not the fear. There is a part of you that feels the same when you are 5 years old and when you are 80 years old. That I am presence is the quantum signal. It is the constant carrier wave beneath the noise of the modulation. That signal was here before you were born, and it will be here after you die. Imagine that you are a violinist playing a beautiful, complex solo. The violin is your body. It is made of wood and string. It is fragile. It can break. Eventually, the wood will rot and the strings will snap. The music will stop resonating in the room, but the song, the melody, the mathematical structure of the notes, the emotion it carried, is not the violin. The song exists in the mind of the composer and in the hearts of the listeners, and in the abstract realm of music itself. The violin is just the way the song enters the physical world for a moment. You are the song. Your body is the instrument. Do not mourn the instrument too much. It was made to be played and then laid down. But the music is written in the fabric of the vacuum, and the universe never stops singing. However, if death is just a shift in perception, and if our current reality is just a simulation created by the collapse of the wave function, then we have to ask, how much of what we see right now is real? If our brain is a filter, and if we are creating our own timeline, and if death is an illusion, are we living in a hologram? Is the solid world around you just a projection from a 2D surface at the edge of the universe? In the next chapter, we are going to explore the holographic principle. We are going to look at the idea that the entire three-dimensional universe, the stars, the galaxies, your house, your cat, is actually a projection of information stored on a distant, two-dimensional horizon. We're going to ask if we are living inside a cosmic movie, and if so, can we change the script? We're going to peel back the final layer of the onion. We're going to ask if reality itself is the ultimate illusion. Rest now in the eternal. You are safe. You are infinite. You are the light that does not go out. In the quiet solitude of the early morning, just before the sun begins to paint the sky with the first tentative strokes of dawn, the world often takes on a strange, dreamlike quality. The edges of the furniture seem a little softer. The shadows seem a little deeper. For a fleeting moment, the solid reality we take for granted feels thin, like a painted backdrop on a stage that might tear if you lean against it too hard. We usually shake this feeling off. We rub our eyes, drink our coffee, and tell ourselves that the world is hard, heavy, and real. We tell ourselves that space is deep and matter is solid. But tonight, in the final chapter of our journey together, we are going to explore the possibility that that fleeting, dreamlike feeling is actually the truth. We are going to explore the possibility that the three-dimensional world you see around you, the chair, the walls, the stars, and even your own body, is a projection. We are going to look at the holographic principle, and we are going to ask if we are living inside a cosmic movie, a vast simulation of light and information, where the only thing that is truly real is the consciousness that is watching it. To understand this idea, which is widely considered one of the most important breakthroughs in modern theoretical physics, we have to go back to the most mysterious objects in the universe, black holes. For a long time, physicists thought black holes were simple. They were cosmic vacuum cleaners. Stuff fell in, and it disappeared. But in the 1970s, Stephen Hawking threw a wrench into the works. He discovered that black holes are not completely black. They radiate energy. They glow very faintly, with what we now call Hawking radiation. Over billions of years, this radiation causes the black hole to lose mass and eventually evaporate completely. This created a crisis in physics known as the information paradox. If you throw a book into a black hole, the information in that book, the arrangement of the letters, the structure of the paper, passes across the event horizon and is gone. If the black hole then evaporates into generic radiation, where did the information go? Remember, quantum mechanics says information can never be destroyed. If the book is gone, the laws of physics are broken. The solution to this paradox came from the brilliant minds of Gerard 't Hooft and Leonard Susskind. They realized that when an object falls into a black hole, its information is not lost inside the volume of the hole. Instead, the information is plastered onto the surface of the event horizon. It is scrambled, yes. It is turned into a chaotic soup of data, but it is preserved on the two-dimensional shell surrounding the black hole. Think of a soup can. The soup is inside the three-dimensional volume of the can, but the label, the description of the soup, is on the two-dimensional surface of the can. Susskind and 't Hooft proved that you can describe everything inside the black hole just by looking at the surface. Then they took a leap that changed everything. They realized that this principle doesn't just apply to black holes. It applies to any volume of space. They calculated that the maximum amount of information you can pack into a room or a planet or a universe is determined not by its volume, but by the surface area of its boundary. This led to the holographic principle. It states that our entire three-dimensional universe, with all its depth, its galaxies, and its vast distances, is mathematically equivalent to a two-dimensional field of data painted on a distant cosmic horizon. Imagine a hologram on a credit card. It is a flat, two-dimensional piece of plastic, but when the light hits it at the right angle, a three-dimensional image of a bird appears. You can look at the bird from different angles. It has depth. It looks real. But if you try to touch the bird, you touch the plastic. The bird is a projection. The reality is the data on the surface. What if you are the bird? What if the you that feels like a solid body moving through three-dimensional space is actually a projection of quantum information stored on the edge of the universe? What if your movements, your thoughts, and your entire life are the decoding of a two-dimensional script? This sounds like the plot of a science fiction movie, specifically The Matrix. And indeed, the simulation hypothesis, the idea that we are living in a computer simulation, is a close cousin of the holographic principle. But the holographic principle is not science fiction. It is the result of rigorous string theory mathematics. It suggests that space is not a fundamental thing. Space is emergent. Space is what happens when quantum entanglement stitches the data together to create a sense of depth. So, if the world is a hologram, what is the light? What is the beam that shines through the data and creates the image? This brings us back to the start of our journey. It brings us back to consciousness. In a hologram, the image only exists when the light illuminates the interference pattern. Without the light, there is just a meaningless scramble of lines on a film. Perhaps consciousness is the light. Perhaps the universal mind, the zero-point field, the quantum soul, is the illuminator. The information of the universe exists in a state of potential on the cosmic horizon. But it only becomes real. It only becomes a lived experience of chairs and tables and kisses and sunsets when the light of consciousness shines through it. You are not just the actor in the movie. You are the projector. This synthesizes everything we have learned. We started with the hard problem, asking how matter creates mind. Now we see that matter doesn't create mind. Mind creates the appearance of matter. The brain is not a meat machine. It is a holographic receiver. It is a lens that focuses the cosmic data into a sharp, coherent image. We looked at entanglement, the spooky connection between things. In a hologram, every part of the film contains the image of the whole object. If you cut the film in half, you don't get half a bird. You get the whole bird, just fuzzier. This explains why we are entangled with everything. We are all made of the same holographic film. The separation between here and there is an illusion of the projection, not a reality of the source. We looked at time. In the holographic view, the data on the horizon is outside of time. It is a static field of information. Time is what happens when we scan the data. Time is the movement of the spotlight of consciousness across the field. This explains why the future can affect the past, because on the data disk they are written next to each other. We looked at the quantum soul. If the body is just a holographic projection, then death is simply the spotlight moving to a different part of the film. The character on the screen dies, but the light does not. The light pulls back and illuminates a new story. This perspective is the ultimate liberation. It tells you that the heaviness of the world is a trick of the light. The problems that seem so solid, so insurmountable, are just shadows on a screen. You can change them. If you change the frequency of your consciousness, if you change the way you look at the world, you're literally changing the interference pattern. You are rewriting the hologram. We often feel trapped by our circumstances. We feel that reality is a cage. But the holographic principle hands you the key. It says, there is no cage. There is only information. And you are the reader of the information. As we come to the end of this long night of exploration, I want you to look around your room one last time. Look at the walls. Look at your hands. Do not see them as dead matter. See them as shimmering fields of data vibrating with the intelligence of the cosmos. See them as a miraculous magic trick that the universe is performing for itself, just to see what it looks like. We have traveled from the neurons in your skull to the edge of the event horizon. We have looked at the ghost in the machine and found that the machine is a ghost too. We have found that the silence is not empty, but full. We have found that you are not alone, but connected to every star and every soul in the deep, entangled web of being. Science is often seen as the destroyer of mystery. It is seen as the thing that explains away the magic. But the science of the 21st century, the science of the quantum, the holographic, and the conscious, is doing the opposite. It is re-enchanting the world. It is showing us that the mystics who said all is one and life is a dream were not just speaking in metaphors. They were intuiting the fundamental structure of physical reality. You are a mystery. You are a paradox. You are a finite point of view on an infinite landscape. You are a child of the universe, growing, learning, and evolving toward an omega point of total understanding. The night is ending now. The sun is beginning to rise. The photons from that star are hitting the atmosphere, scattering into blue, and entering your eyes. Your microtubules are vibrating. Your wave function is collapsing. You are building the world again, fresh and new, with every blink. What will you build today? What kind of movie will you project? The script is in your hands. The light is in your heart. The universe is waiting for your command. Thank you for taking this journey into the quantum mind. Thank you for daring to ask the big questions. Thank you for sitting in the dark and looking for the light. Keep wondering. Keep exploring. And never forget, you are not just in the universe. The universe is in you.